I know we are paying that a lot of attention right now, which is a lot of the happening through, especially for the solar wind. A couple other examples. I brought that screen so we can discuss more in the pipeline perspective. So it's a great thing. We typically, as the community, we focus on building the good quality, secure application. We often forget how to build it. How to build is the key point, like where we are building, which is a software pipeline. So if you look at this picture, this is the section, and we typically use right here, this is our pipeline, which has left a little bit bigger, which has the continuous integration, continuous delivery, other practices that we have. This is our pipeline. But if we don't secure this pipeline, what that means securing pipeline? Let's say I'm a developer. I'm right here as a developer, and I'm going to use, right there, I'm a development team. I would like to use some of the libraries and to achieve my code, because typical current developers and as an engineers, we are so much complexity that we have in our environment. Like if I'm going to write a code, I just go to Google it and go to GitHub to get something is available for me. I don't want to reinvent the wheel because we are racing with the time. So with this rationale behind it, I can get the libraries put into my pipeline. That's going to be part of my continuous integration example. So suddenly I'm inserting X library here into my build process, which is how we're getting the open source, which is SBOM component. Second component is how are we going to securing as the configuring of this pipeline. Let's say we have a continuous integration that we have a continuous deployment. In the continuous integration, we might be using some build server like maybe Jenkins, just to make it more realistic example. In the Jenkins, and I'm giving another one example which happened recently in November, we're using some static analysis tools that we may have for security perspective. So if you don't configure these two tools properly, now we are opening up a vulnerability for the people who can attack it. So now it looks like we are in the perimeters of a network infrastructure that we are protecting. But if you don't configure each of the tools that is part of your pipeline, it's opening up an attack vector. People can take an advantage of using one of the Jenkins configurations back to you. Even though almost every tool vendor are describing here's the best practices to set up your Jenkins, set up your GitLab, set up your Docker, set up your Kubernetes, it exists already. As a practitioner, we just go and download and grab it by default and then try to install an environment without even thinking, all right, how can I make sure that I have a good secure implementation of this component? How are we going to make sure that Jenkins is able to segregate multiple builds in the build steps build perspective? So we have to step back, think about that, how we are thinking about application security. We have to think about as the pipeline itself, and how can I secure the pipeline? How can I secure means how can I configure it properly? And then how can I be ready for any type of outage in the pipeline? One specific example I can give, which actually happened a couple of years ago, one of the smart, I'm going to say hacker people, they used one of the build agents and then put a data mining vulnerabilities into the build agent as part of the build server, doing data mining through the pipeline. It's a great idea because build is keep running, and then you don't really pay attention how the build is acting. So you're giving it free resources for adversaries and taking advantage of build agent and running a data mining on the build agent, doing some other process as part of it. How it is get there, which is about the lack of configuration, lack of not monitoring libraries. And then we don't have a monitoring that we discussed at the second question, I believe. If we don't have a good monitoring, how are we doing well, how the system is behaving, there is no way we can capture any type of abnormal activities as part of test scenarios. So we have to configure as a summary, we have to configure our pipeline, make sure that we are following best practices. We have to be ready by monitoring any abnormal behavior of the test or the build stages. And third one, we have to have a full traceability. Who is accessing our libraries, our pipeline, what they are changing. Like we should establish the good, secure commit process into the repositories. We should have a kind of SSH, or we should have a tokenized, we should have a cryptographic deployment. We're going to make sure that we are accessing the pipeline as an individual. We are following the best practices as well, Shane. Good morning, good afternoon, good evening, where you are. DevSecOps Days Pittsburgh event is going on. We have a great speaker lineup and Tracy Bannon with us today right now. So she's going to talk about how we shift left the security into the DevSecOps lifecycle. Before that, and Tracy, she has a passionate an architect. And Tracy, she's talking more about the architect perspective, which kind of ignore most of the time. We never really think about that. We always go fast and fast and fast. Sometimes we fail miserably because we ignore the architecture. And Trace has a passion on it, and I know her for a while, and she's a great companion and talking about the architecture, talking about the people element, talking about the culture aspect of it, and to achieve the DevSecOps or DevOps practices. Without further ado, I would like to introduce Tracy Bannon for her great talk. Tracy, the floor is yours.
Hey, thank you, Hassan. I appreciate that intro. And yes, we have become really good colleagues. We've been working together quite a bit for a couple of years now. Folks, today I'm going to talk with you about something that I call no hobbyists. Now, you'll start to understand that as we go along. But there's a dramatic shift of cybersecurity. What do we do with cybersecurity? And I am coming at this from a software architecture perspective. Now, I'll give you just a little bit of information about myself, a little bit more than what Hassan gave you. I am an architect. I am an engineer, and I'm focusing on solving problems with software. I do work with the MITRE Corporation, and sometimes they call me a DevSecOps strategist. It doesn't matter what you call me at the end of the day, it's all about getting value into the hands of those end users. So there's going to be a lot of detail throughout this, and on every slide, I'm not going to cover everything. You'll get a copy of these materials, and there are also some links that you can chase down to give you more information, and we can also talk outside this. But let's get started. All right, here's the shocking slide. All of the things that you're seeing are about a month or so old, starting in mid-February. We're in mid of April. Okay, 8 weeks old. But look at the amount of vulnerabilities. And these are really visible ones. If you visit some of the different, I think it's PortSwagger is one of the sites, there are multiples that are tracking and allowing us to understand what's happening. It's everywhere, right? We are all aware of this tremendous cyber effect, cyber warfare that's going on, that's impacting us every day. So what does that mean? It means that there's a lot of emphasis on shifting left. We have to quickly shift cybersecurity to the left. But, you know, we started by saying we're going to shift ops left, and we created an infinity loop, and we called that DevOps. And then we said, well, we need to put sec into the middle of it, and we now need to shift it. But there's a trend on shifting left. And if you look at this slide, hopefully you can see that slide, shifting left does mean that security activities have to start at design, and entire SDLC security mindset is a part of it. From vision through operate, yes, there has to be continuous feedback at every loop. But I actually don't advocate just shifting left. And this may shock you, but I actually advocate we shift everywhere. It may sound hokey, it may sound kind of silly, but really cybersecurity, cyber resiliency is everybody's responsibility. So cybersecurity needs to be ubiquitous. The picture on the right-hand side, it really indicates that security surrounds everything. Now, earlier today, you heard Chris Hughes mention that unless you're a security company, security is not your business, but security needs to not be something that's bolted on. It's not a feature that gets added later. It does need to be a core part of anything that you do. So don't shift left, shift everywhere. But shifting will fail unless you take a step back and you're holistic. So we hear the terms people, process, tech. I'm going to branch that out to be 4 things: people, process, tech, and culture. And if you're not addressing all 4 aspects when you are trying to shift, you're not going to be successful. And you have to think about autonomy for people, upskilling, what their roles need to be. Technology, we need to understand how new technology can be inserted. What are your digital platforms? Well, what does production really look like for your organization? And culture, there's this aspect called psychological safety that you really need to think about. That means the ability for me to raise my hand and to say, something's not right here. And collaboration requires that psychological safety. So either way you're shifting, left or both ways, You need to address all of these aspects. So it sounds logical, right? Sounds great. I'm with you, Trace. Okay, let's do this. How do you do it? Well, you have to start by building a new culture. One thing that you won't hear me say is you need to change your culture. Changing your culture is kind of, well, it's really difficult to just say, I'm going to change. It's like getting up tomorrow and saying, I'm going to change to having a healthy lifestyle. I'm better off saying I'm going to build a healthier lifestyle. I'm going to build a new way of learning, a new way of thinking. So start by building a new security-centric culture. So define your unifying cybersecurity principles together, agree on the roles and the responsibilities. Now, I'm going to cover with a little bit more detail on your security software development framework. It's called your SSDF. You've got to start to work elbow to elbow and demonstrate those model behaviors. That is going to allow you as an organization to build a cybersecurity culture together. Let's move forward. So don't start from scratch. You will need a cybersecure development framework. You have to get together and agree on what these pieces and parts are. I recommend looking at NIST. They've got the 800-218 is a great publication. It will tell you what to do. You'll have to define the how. But again, going back to that culture building, pull your folks together, sit down together and discuss these topics. Define your roles and responsibilities. Figure out the types of security training that are relevant for your organization. Together, define those things. Agree on what your secure coding standards are going to be. Think about what that secure development lifecycle is. So I'm throwing a bunch of different things at you, but at the core of this is your organization agreeing on these things together. If it's a mandate that comes from outside, if it's a mandate that comes from a third party, if it's a mandate that comes from a singular office within your organization, and you're not all working on these things together, you're going to have a lot of adoption challenges. You're going to have a hard time shifting your culture, building your culture together. So one of the things that I really love to do is to threat model as a team. If you're not familiar with threat modeling, there are really 4 questions that you ask. Now, I'm not going to teach you all of the ins and outs of threat modeling, but together, get together and talk about specifically what is the component or what is the feature or the aspect that we are going to work on and what could go wrong. You'd be surprised when you have the business, functional analysts, operations, cybersecurity, developers, people who have been QA focused. When you get folks together and start to say what could go wrong, you'll be amazed at the different vantage points that are going to be brought to the table. You automatically start to understand each other. You automatically start to understand the security issues that can arise. So then what are we going to do about it? Figure it out together. I'm going to keep foot stomping on that word together. And then the final aspect of it is it says here, did we do a good job? But it's validating, did we take the steps and did we act on them and how did we do? So it's a little bit of a retrospecting. So if you're going to build a cyber secure culture, if you're going to be cyber secure centric, if you're going to shift it ubiquitously, try threat modeling as a team sport. So if you're a developer, and I spend a lot of time as a developer, you're probably saying, is it time to code yet? Not yet, not quite. The developers will probably be experimenting with their IDEs right now, and they're exploring some of the techniques. But the challenge here is that you're saying shift left and telling the developers, hey, go get smart. So they're probably trying to do that. They're probably hobbyists right now trying to figure out, what does that mean for me to shift left? What's it mean to dump security onto development? That's the mindset that happens. So what's a security hobbyist? Well, it's placing responsibilities on developers or delivery teams. It's constantly having the addition of new tools. Means that training lacks depth. It isn't just a quick brown bag one time, it's ongoing training. There's a continued pressure to go fast, and people are reading and experimenting on their own if they have that time at all. I love the sentence that's at the bottom of this, and we need to shift our minds from thinking that developers are somehow experts already on security. I love this. They're not waving magic wands to cast spells to defend against the evil hackers in the black hoodies. We do want them to grow and become those security pros. Let's talk about how we get there, though. So no hobbyists. How do we go from hobbyist to pro? Well, we need to protect them and we need to enable them. So there's training and education. We'll get into each one of these concepts in a little bit more depth. Make sure that you are secure by design. Use secure coding standards, design patterns. I am all about design patterns. If somebody's already figured out a way to do it and they have it articulated so that you can look at those constructs and determine if it's right for you, why would you try to do it a separate and different way if you have an explored, repeatable way? Encouraging experimentation. This is really hard, especially as we want to go faster, where we're afraid, especially in the government space where I spend most of my time, we're afraid of some types of experimentation. But if we're going to help development teams, delivery teams, we need to double down on different tools that are going to help them to reduce noise and that cognitive overload that can come with it. So let's talk about upskilling and training developers. So I personally adhere to something called the 70-20-10 model. This is nothing new and I didn't invent it. Gosh, I believe it's over 20 years old or more. Essentially, 70% of the education needs to be experiential. It means hands-on. I start with that table stakes formal training. It could be classroom. It could be that it is with an online training, but it is normally more of a push. And it's normally gets you those, well, the first lexicon, it gets you your taxonomy, it's your basics, but it's not the hands-on that you need to really take it from learning to true understanding and mastery. So I've covered the 70%, I've covered the 10%. What's the 20? Well, that's the informal, that's the social driven. What we're doing today is somewhere between formal and social. So you need to augment and create cybersecurity opportunities for the trainings that follow this type of a model, making sure you're giving the foundations, but then making it on the job experiences. So let's talk about that 90%, not the 10% that's formal, but let's talk about the 90%. What does non-classroom training look like? I can tell you some things that I do. I run a team hackathon and we use OWASP. In particular, I like WebGoat. Some folks like Juice Shop. The links are here. Run a hackathon together against a production version. Go ahead or get a release candidate that's coming out and work against that together. You'd be surprised how fun it can be, but how you learn the tools, especially when it's real. And you're using these tools. Join a competition. MITRE has something called the Cyber Academy. They have a gamification engine. There are other gamification engines, but join a challenge as a group. Again, teamwork, getting people together, and it doesn't just need to be the developers that do this. Pair program with your SAST tools. Those are your static application security testing tools. If Hassan and I were co-located and he's running that SAS tool against the code that I just ran, we're going to be able to discuss and learn about the mistakes that I made, but we're going to be able to do that in a psychologically safe way and learn those tools. And then finally, something that I really love, storm the castle. So what is storming the castle? It means have a lunch event. Use something like OWASP Zap and do some dynamic application security testing together, right? Lunchtime, let's storm the castle. Let's try to bust into this thing. Let's try to figure it out. Oh my goodness. So is it time to code yet? Is it time for us to code yet? Developers among us are saying, yes, it's time to code. Sort of. Probably, but not production quality capabilities quite yet. You're still learning. That's okay. We're still experimenting. That's okay. We've got some other things to do, especially netting out what our design principles are. So design is this guiding principle. I'm going to read this quote directly to you. Design is a guiding principle for how a system is built, and it's applicable at all levels from code to architecture, and it includes an activity that involves active decision-making. So I bring this up because we have to be thinking about being secure by design. So design is a thing, architecture is a thing. Everything is not simply emergent. We don't simply put together an agile team and say, go and do. You have complete autonomy. We have to be thinking about security by design. So security by design means it's security is a concern and not a feature. It's not just a user story in your backlog that you're going to bolt this one security aspect on. Security means that throughout all aspects, my pipeline needs to be secure, my environments need to be secure, the code needs to be secure, my testing needs to be secure. It's thinking explicitly about it. It's understanding the context for your business. Your archetype matters. Your security will be indicative of the areas that you work in. If I'm working with the military, that's one type of security concern. If I'm making an application for you to order a quick pizza, I'm going to have a different set of concerns. But focus on your domain and understanding specifically what happens in your domain. There are many security bugs that can be caught implicitly because of your knowledge of your security domain for your business. So some secure coding practices. This is another important part. If we're going to have that security culture together, we need to identify what our secure coding practices are. Look at the numbers that are here. 82% of software vulnerabilities are from coding. That means 82% of the vulnerabilities are originating with a human. So identify the secure standards, make sure everybody knows them, run tools to verify that you're achieving those standards, right? You can scan the code, you can see that stuff, and allow the developers, help them to do the scanning themselves. Don't just hand it off to somebody else to do scanning. So I'm just going to flash this screen up. These are some examples of secure coding standards. There are many. And on the right-hand side, you'll see a number of different practices. This is important, but it's bigger than what we have time for today. So be aware, you've got to net down what your secure coding standards are for your organization if you're going to reduce the number of hobbyists in your group. So is it time to code yet? Yeah, we're getting there. It is time to dedicate to understanding your dependencies. The developers are starting to do their work. The architecture has been netted out at the highest level. Start documenting your project and program dependencies. Align your streams. I tend to not say project teams. I tend to say stream aligned teams, but align those streams to your secure development framework. Start running software composition analysis and start to look at creating your SBOM. So you've got to figure out what your dependencies are. But I'm going to foot stomp back. Remember the word I said earlier. This is all about together. This is all about making sure that people have accessibility and transparency into all of these different capabilities. So I love this slide. I love this slide. We need to teach people how to break things. Do you want to know why? Because developers don't break things. We're builders. If we are normally focused on how do I shore this up? How do I make this thing? How do I build the bridge? How do I build the skyscraper? I'm not always thinking about how can I tear it down? So it's a great thing to give people the opportunity to practice breaking things. So we talked about some of the games earlier. We talked about some of the activities earlier, but it is a different mindset. And I have found, being dev, married to ops, I'm married to an operations guy, that he's better at breaking things than I am. And so sometimes I just need to run things by him. Sometimes I just need to talk about, so imagine bringing ops, dev, security, bringing us all together and talking about breaking things and then helping people to think about that. It is akin to threat modeling, not exactly the same, but it is a mindset shift for folks. So everybody needs to learn to love application security testing, AST. And these are the different types of security testing. Earliest detection is your static AppSec testing. Dynamic happens, it's an outside perspective. Normally you want to do this before it goes into production. You might have agent-based gray box testing, that's that IAST. And then we've already covered software composition analysis. So again, I'm coming at you, I'm throwing things at you very quickly. But what I want you to take away is that You need to learn to love security. You need to learn to love and be passionate about testing. You need to be passionate about breaking things. You need to be passionate about experimenting. Once you start to do these things together, your culture will really start to grow up together. This is important though, gang. There's just too much code. There's just too much code to handle by the humans. We can't do all of this just by giving Tracy, Hassan, Chris, Bryan, just can't give us some training and think we're going to be able to get this all done. We need to be able to look at and understand the tools that are emerging and that are available to us right now that will help us on this journey. So these are some tools to help and the developers, and this is just a teeny, tiny sample. You see the Threat Dragon from OWASP is a fun one. There is the Threat Modeling Cookbook. You'll see a number of different things from OWASP here. They are a favorite of mine. Having taken a fantastic grad course in ethical hacking and working with a woman by the name of Katie Craig, I've just come to appreciate being able to go out and the ease of bringing these things internal. There's some interesting stuff that's happening with automated code security remediation. That's right. Imagine I can run White Source's tool called Cure against my code, and it will provide you with a list of candidate remediations. You can choose to accept them or not, and that's part of training the model. But imagine how important that is going to be to us in the coming year and 2 years, that we're going to be able to remediate those security issues in our code base by leveraging machine learning and algorithms. Everybody knows about SonarQube. And if you don't, do a quick Google and check it out. It is your code quality. It's your SAST. Git Guardians has really good secrets detection. That's something that you're going to need to be aware of. Where are your secrets held? How are you making sure that you're managing those together properly? And you see a couple of things around dependency scanning. My point here is there are awesome tools that are on the horizon. There are awesome tools that exist already. Don't overwhelm people with tools, but think very intentionally, what's the value of this tool? Is it going to reduce cognitive overload? Is it going to reduce risk? If it has those two core pieces, then start to evaluate what's its uptake into my organization. This is just another way of saying, together, figure out the tools that you want to use and give people the time to experiment with them. So security, everybody's responsibility. So everybody needs to be equipped. If we're going to shift, let's shift ubiquitously. Let's make sure that we're not making anybody a hobbyist. Let's provide the education. Let's do it using that 10, 20, 70 rule and make sure that beyond my book learning, I'm hands-on, I'm shadowing people, I'm working on those problems. If I have the ability to give somebody, if there's a defect or a problem, and it isn't code blue, has to be fixed in the next X number of minutes, I may bring somebody junior along and say, let's work this out. You take lead. I will shadow you and follow and help you as your mentor. Think about opportunities to be able to lead that way and be a servant leader from an education perspective. So I know I ran through these materials very quickly, but I wanted to give an opportunity for us to answer any questions that folks may have. Hassan, let me turn it over to you and see if there are any questions or if you have some questions for me.
Thank you so much, Tracy. It was a great journey to look at the life cycle perspective. And I guess we can start the code right after this presentation. I'm still waiting to see, can you start the code or not? I have been hearing this similar response and from my students when I give them a project. Oh, I can write the code. I can Google it and copy and paste and get it done quickly. No, just wait. It's a great analogy. I like that, Tracy. So we have a question from one of our audience. A question about many projects are based on libraries that people are making in the past, which is not current. And how can we control the job that others make and affect all of us?
So putting my architect hat on, it depends on where the library came from. Is it external to your organization or is it internal to your organization? So step one is figure out what its origins are. Step two is understand, how it's being leveraged within your organization. Step 3 is understand the quality of that within your organization. I don't think there's necessarily a one size fits all. Libraries are not necessarily a bad thing at all, right? We want to be able to have reusability, but you do have to have a code quality of any of those reusable components. If it's something that has been created inside your enterprise, make sure that you understand how it's going to be managed and maintained. One of the places that I see probably the greatest proliferation of bugs is that we've created something, I've created it, and I say, Hassan, this is really awesome. You got to use this. And he does. And he assumes that it's working really well. And when he has a problem, he comes to me, and I might not have the bandwidth or the budget or the time or the imperative to help him. So the enterprise needs to enable us to be able to take control of this.
Great, Tracy, thank you. Maybe we can talk about SBOM as a parallel as well, right? This is bill of matter that we are talking about, extension of the known libraries and ownership.
Exactly.
So I'm going to a little bit challenging on you for I know you like the architect, you would like the pressure on it. There are a lot of pushback from the community is architecture is blocking us. How can we I'm hearing. DevOps
I'm hearing it too. I'm hearing it too.
Test and coding. And if it does not align with architecture, or if you look at the code analysis that you did a great example, like 82% of the software vulnerabilities are from coding errors. Do you have any insight, like how much architecture will help to eliminate the vulnerabilities in coding error?
I think I need to find out what a specific qualitative value will be against that, or quantitative value will be against that. I can tell you from experience, when it comes to architecture, one of the places that we failed in the past was big, huge, upfront strangulation architecture. Everything was defined, and then all I would do would be to throw over some code snippets, and I would expect developers to replicate what I thought. That's not what architecture needs to be. Architecture needs to be enabling without disabling and allowing there to be autonomy by others. So that's a tough balance. Architecture needs to be focused on making the decisions that will be costly and high risk to fix later. So I need to have enough experience to think through the trades up front of what can we not back out of. If it is going to be a particular, something that is a highly proprietary format of data, for example, I need to talk about what is the cost of leveraging that, how difficult will it be for us to pull away from that, and then what are the coding standards that I want everybody to follow for that. It's not one size fits all, but architecture should not be heavy just to be dictatorial. It needs to enable without disabling.
And also I'm going to build up as well, which goes back to the business requirements, business perspective, because we design our architecture of the system to meet our business needs.
We should.
There was a question actually in Chris's presentation, like how can we overcome the business request? The business says, I need to get delivered this functionalities as quick as possible. Now we are building the system. We just jumped the code right away. Now we are saying, let's pause it. Think about our architecture first. Think about the design criteria first and go from there, right?
It's a balance. Thinking about your architecture, and I don't just mean sitting around and thinking and looking up at the trees and the clouds, but being intentional about some of your design decisions is an important part. Your business needs to understand, you need to bring them on the journey of what are the risks if we don't do this. I can tell you, the business understands, especially if it's a non-governmental, commercial understands angry customers. They understand when their call volumes go up. They understand when the chat bots that are being used for online service are ringing, are registering a tremendous number of hits. They also understand the beauty of having an increased customer base because social media is messaging out about how great something is, because there are new incremental secure features that are being provided that delight users. So they understand the role of that architect is to be able to translate between all these different folks. I tend to put architecture as a hub communicator mentality. And so that's part of my role, is to help bridge that.
So technically you are saying that let's get the security part of the quality attributes, which it is, but we're not ever able to go and say that security is one of the quality attributes. How are you looking for the performance, modifiability, or maintainability? Security is one of them. Let's get it done.
Exactly. Quality attributes.
Exactly. We should do that. So Tracy, it was a great presentation, great discussion with you. Thank you so much for your participation. We're looking for you in the future event and hearing more of you, your stories and your journey, and we can start the code finally.
There you go. It's time to code, folks. Let's go. All right. Thank you very much, Hassan. Thanks, everybody.
Thank you. So
have a great day.
We will continue for our next session in 10 minutes, and we have speakers from the Cynic, and Steve Kinman will with us at 10:50 a.m. Stay tuned us, and we will continue our DevSecOps Days in Pittsburgh event.
see many different type of implementation in terms of DevSecOps practices and in terms of the different understanding, as this subgroup is really helping the common understanding of what the DevSecOps culture should be in the DoD context, like maybe describing the playbooks, describing the framework, describing the vocabularies, describing acquisition perspective, and it is giving a guidance to the rest of the DoD, follow it. Remember that the software factory concept we discussed, we are looking for the same practices, same process, a different implementation. This is exactly DoD DevSecOps working group we would like to do, which is doing it already. There's already, we can post the URL into the YouTube channel, and people can download the latest version of DevSecOps framework and playbook and some other guidance that come from the US CSO Air Force as well. It's going to help us to understand what the commonalities of building up a continuous improvement, what the key capabilities are. You're looking for what the DevSecOps pipeline means, what the continuous integration means, what the continuous authorization means. So it's going to describe the vocabularies and describe the common understanding, and also giving some reference architecture. Let's say you would like to use the Kubernetes and Docker, here's different architecture for you as an organization. You can follow that reference architecture, build up your own Kubernetes container-based DevSecOps environment. And then another things also, it's important to mention here, Shane, and a little bit about the container as well. It's also offering hardened containers, so rest of the DoD folks can use the hardened containers. What really means, and in the DoD context, we always would like to have an approval for the software. Without having an approval, none of the software and system will go into the production environment. It is requiring authority to operate, which is AO, and then we are adding a continuous ATO. So continuous ATO, authorized to operate, is continuously requiring a constant evaluation, constant check of the libraries, dependencies, application with respect to security. What the DoD DevSecOps initiatives is really building as hardened containers. The hardened containers has already approved dependencies libraries for one of the modules that developer might be using it. That module can be a Node.js, can be one of the pipeline component, can be a GitLab, can be a Jenkins, maybe data science using some Jupyter, some other tools, has approved already in the available public platform. And then people in the users, they can pull that libraries from the common portals and use in their application context. We can cut the reapproval process in our approval components. So we can use the approved containers to speed up our approval process so we can go faster. So that's another thing as the DevSecOps initiatives groups is helping. There are many other activities as well as part of this group. And there is embedded software development group is happening right now. We haven't really published as yet every output, so still is building up. How can I use the embedded software development DevSecOps context? And there's another studies happening as part of DevSecOps group. It's about digital engineering. And there's another connectivity between digital engineering and DevSecOps. I think there's a webinar we did a couple of months ago. And there is a direct connectivity. How we're setting up our digital engineering ecosystems on a software pipeline, which is DevSecOps pipeline. We can go back and use in the digital engineering concept using a source of truth. Other component will be part of it. So it is giving a good guidance and DoD. At the same time, a lot of industry folks also using that. How can I use a typical DevSecOps framework in a highly regulated environments, like the health industry or the finance industry are good examples of consumers of the DoD built DevSecOps framework.
Hello, everybody. My name is Jeff Hammond. I am a DevSecOps engineer here at the Software Engineering Institute. Thanks for joining us for DevSecOps Days. Very happy to be introducing our next group of speakers. First up, we have Steve Kinman, who is currently the field CISO at Sneak. Steve has 20 plus years of experience in compliance-driven security strategy knowledge. And with that said, I'd like to kick it over to Steve, who's going to be talking about software supply chain risks.
Thanks, Jeff. And hello, everyone. Thanks for joining my talk. As Jeff said, I'm Steve Kinman. I'm the field CISO for Sneak. One sec here. Let me enter my authentication code. I know I have it somewhere. 634506 and authenticate. Okay. I've verified who I am. So y'all can all trust that I am who I say I am now. Multi-factor authentication, you have to love it. So as Jeff mentioned, I have a long history of risk, compliance, and security work, including a CISO role in Germany. But I need to make one confession. I've never been a developer. So much of this talk today will be a security view on developers working in the software supply chain. So today I'll do my best to help you decide if we are forever doomed by software supply chain risk. Since I know swag is important, at least it is to me, you'll notice a QR code on this slide, the next slide, and even the last slide. You get one last chance on the last slide. So be sure to scan it, and Sneak will send you a t-shirt. So if you join today, it means you care about software and you care about software security. And if this is true, then by default, you must care about open source software security, since open source modules are the building blocks we all use. Or maybe you just wanted a free t-shirt. So remember the code, bottom left corner, go ahead and scan it. I'll wait. Okay. So for real, here we go. So what do you see when you look at this picture? What comes to your mind? Is it just another day in our futuristic world? Do you wonder what the robot is teaching or perhaps learning? I'm curious if it can bring me a coffee, but maybe today is the day it also decides to take over the world, the great uprising. As a CISO, this pic makes me ask myself, like, how much is the robot learning about the child, its surroundings, the network it's connected to, GPS location, all of those things that you fear the most, I think. And then I think about where are those interactions stored? And are they stored safely? Who has access? What's the data used for? How many data sets and algorithms is the data now a part of? Is it only used in aggregated form, or is it accessible as human readable, personal, identifiable information on an unsecured S3 bucket? Since I was a CISO in Germany, it's natural that I focus on data aspects first, and the governance and the rights of someone to process the data. But for the security side, I wonder about the software on the robot. Where does it get its updates? Who's writing those updates? And can this upstream source be compromised? What happens when it does get compromised? Then I think about what a malicious download could do to the inner workings of the robot, how much data could be compromised, and how the robot might act differently. So with malicious code, can a human watch the video feed and interact with the child? Can the device always be monitoring the environment? I think we've all heard stories like this in the news, and needless to say, it's thoughts like this that really keep me up at night. So to dive a bit deeper into the topic today, I'll share a few real-world stories related to software supply chain security and how it affects us all. I'll discuss why we should care about software supply chain security and what the landscape looks like, how developers play a fundamental role in security incidents and even preventing them. And I'll show how this problem continues to grow. All of this information should help you gauge who you can trust as your daily routine continues to be overtaken by software. Have you ever thought about how many applications you use and how many IoT devices are in your surroundings? Just for fun, this morning, I checked my home router application, and there are 37 devices connected to my Wi-Fi. Most of these are phones, computers, and TVs, and all of those are full of applications as well. 2 of them are actually cars, which are also full of applications. So this is just a real world example of why application security is important. In order to understand where these supply chain risks come from, let's discuss where we are today and where we came from related to the software and application evolution, or revolution maybe. Let's go into the time machine. So Mark Anderson penned his now famous Why Software is Eating the World essay in the Wall Street Journal in 2011. And today, I believe that every company, to stay relevant, needs to become a software company if they aren't already. You can think about how fast software has changed and accelerated technology over the past 10 years in the way we live, eat, work, travel. It's all changed. Even my elderly parents use tech. I know because I'm still their 24/7 tech support hotline. And boy, do they use me all the time. But they use tech because they don't really have a choice. They have to use it. Applications have become a critical part of everyday life and a core part of almost every modern business. With this explosion of software, can security keep up? It's really struggling to keep up, is what it boils down to. So one of the challenges for security teams is the same thing that has allowed the use of software to explode, is hindering security. It's the use of open source software and modern development methods. In the past, there were many teams involved, tickets that had to be open, tickets that had to be approved, they had to be completed in order to make sure gear was ordered, installed, secured, on the right network, on the right VLAN, etc. Product teams worked on large monolithic projects that were based on, the original plan and very rigid. And you heard things like scope creep and budget overruns. That's what was really cared about. And if those product managers needed last minute changes to a new feature, they had to just wait till Rev 2. Those days for many companies are long gone. And it's much different now. There are large development groups comprised of many small decentralized teams that work on building microservices and components that, when combined, make up the applications we use today. Developers are now armed to succeed and in control of their destiny to meet the product deadlines promised to customers. And to meet those speed requirements, open source libraries are the write it once, use it many times option that these teams leverage. They no longer fire up their IDE and start from scratch. They use building blocks. And these modern development practices incorporate a lifecycle approach, and each section of this lifecycle incorporates risk. And each and every tool they use in the lifecycle incorporates risk, and so forth and so on. When you tie it all together, you end up with a more situation. More open software is being developed, and year after year, there are more open source software repositories. More applications are being built, and they are more dependent on open source software. More software engineers are using open source and becoming accustomed to the ways of the open source community, and more are becoming maintainers of open source software. And more open source software creates more risk. We are continuously witnessing the growth of security vulnerabilities in open source software ecosystems like NPM, Java, and others. And the risk includes CVE-based security vulnerabilities that we all read about. They need to be addressed by using new packages or new versions. But there's also risk related to malicious packages hitting the software supply chain and targeting the developers who rely on those packages. With developers and the tools they use now being the new fashionable target, as can be seen in recent newsworthy breaches and incidents, knowledge of the risk in the software supply chain and all the places they are present in the lifecycle is now super important to development teams and security teams alike. Areas that include open source libraries and dependencies, proprietary code, repositories, and even the build environments in use may lead to further compromise, and this can go all the way to the consumer. So why are they targeting developers? In 2018, the JavaScript ecosystem witnessed its first high-impact spearheaded surgical attack. The attack targeted maintainers and developers working in open source and used their code as the attack vehicle to distribute malicious JavaScript code. The code was designed to decrypt itself and run in a specific environment targeting developers of a Bitcoin wallet application. This was the well-known event stream incident. The event stream module was added to the NPM registry in 2011, heavily downloaded and popular. But in 2018, a new contributor added a dependency with a supposedly genuine intent to improve the code base. A few weeks later, the contributor added a code payload inside that dependency that targeted and injected malware into a specific Bitcoin wallet application called Copay. This was done specifically because Copay used EventStream as part of its build process. This malware went unnoticed for about 3 months and allowed 2 versions of the Copay Bitcoin app to be released, with the malware included. This shows how hidden these attacks can be, especially if you aren't aware of these types of attacks, or maybe you just aren't looking. So as if nothing was learned from that incident, the pattern continued. 1 year later, the Electron native Notify incident took place. A backdoor was maliciously added to the Komodo Agama crypto wallet using an open source project called EasyDex. EasyDex incorporated a package called Electron native Notify, which at the time was malware free. Much like the event stream incident, once the contributor noticed it was in use by the Agama wallet, it was updated to include a malicious payload. Luckily, an NPM security team spotted the attack, and Komodo took a really interesting approach to secure the funds at risk. They actually used the vulnerability to protect the funds. So good for them. If you ever want to know what keeps a CISO up at night, try drawing that scenario on a whiteboard and then incorporate everywhere along that journey where a developer could touch code, and then zoom in on that life cycle, and then keep zooming in. Then question the trust relationships and security due diligence done between each life cycle. It can be a little mind-blowing. And then think about the times in compliance and security. I think about the times in compliance and security where I had the luxury to completely scope out the developer environment and didn't even consider those risks. We did that so we could be compliant and meet regulatory requirements. Yes, I said completely scope them out to meet regulatory requirements. Hopefully there's no black Suburbans following me around later, but who knows? So by scoping out these environments like we did back then, were we not potentially allowing attackers inside the organization with just full unfettered access? It's a potential that could happen. Back to real world examples. More recently, in January 2021, someone broke into Microsoft's Visual Studio code base. Once they were in the GitHub repository, they found they were able to execute commands. They could then execute code without any sort of authentication or authorization check, and were able to run remote reverse shells on the CI servers. From there, they had push and write access to the popular IDE's source code. Fortunately for everyone, this was a white hat researcher who responsibly reported the flaw to Microsoft before advanced threat actors could exploit it. Had this been a malicious attack, the fallout could have been far-reaching and really mass chaos. Maybe this should act as a warning to us all and shine a light on the possible outcomes that could occur if someone was able to add malware to a code editor that millions of developers use each and every day. So how much do we know about the current state of open source security and what it entails? What do we know about the dependencies in use day to day in basically all software? How do we expect security teams to know what they're trying to protect? I say it all the time, it's an impossible mission to secure all this reactively. Here's an example of how to blow a security person's mind. npm.js, probably the largest registry in the world, has around 1.5 million packages for consumption. How do you secure that, first of all? These packages are the building blocks that power JavaScript and Node.js applications. Everyone can use them and publish them, and I've shown examples of what can happen when someone adds something malicious. In 2019, an academic researcher found 61% of those packages could be considered abandoned because they had not received any new updates or releases in the last 12 months. So what happens if a vulnerability is found in an abandoned package? Who are the maintainers? With no way to update, do you stop using it? What if it's critical to your business? So let's take a look at another real world case from a few years back. This is the case of Marked, an open source markdown parser that had a cross-site scripting vulnerability. Marked is downloaded millions of times per week, one of the most popular libraries for this purpose in the JavaScript and Node.js ecosystem. It's an active library with current maintainers, but of course they're just doing the best they can and it may not be their day job. And of course there are no legal or contract obligations stating that they have to support users. In this case, a security researcher opened a code pull request in 2015. He had an aim to report and fix a cross-site scripting vulnerability. The request also included tests for future code regressions as well as proof of concept examples. The vulnerability was left unremediated for a year before it was finally merged and made available as an official release in 2016. It's a long time to have that vulnerability present. With all the dependency on open source software, we can no longer ignore the question of where we put our trust, and we have to know what security controls, guarantees, mitigations, and things like that are in place to reduce risk associated with the maintenance of open source code. Because then we have to think about what happens if the maintainers are compromised. This brings us to an interesting case from 2017. A security researcher working with the Node.js Foundation conducted some research in which he assessed the state of weak NPM credentials used by maintainers. His work revealed that developers lack mature security hygiene. I think most security program leaders would probably agree, but that's a different subject. The researcher was able to gain publish access to 14% of the NPM JS modules due to poor password management. Some of the modules are downloaded tens of millions of times per week and are essential parts of the Java ecosystem. And from a security standpoint, like what could have happened if this was a malicious actor doing this and not a white hat researcher? If these code packages can reach millions of developers, should we not require that more protection be in place? Will this added protection really stifle innovation and speed that much? As a citizen of this software community, both security and developers, we must do better when it comes to security hygiene. And it might start with you. Remember, I mentioned that NPM has around 1.5 million packages that are in use. The good news is that it's supported two-factor authentication since the end of 2017. I will make the assumption that you're all using it, just like I did at the beginning of this talk. Like I logged in with my two-factor authentication, just like you do when you're coding, right? What if I told you that despite all the security incidents and compromised accounts over the recent years that are now happening more and more, that in 2019, only 7.1% of package maintainers have enabled MFA? It's okay, we'll do better. We can do better. Maybe it didn't resonate enough. In 2020, we were only at 9.27. As a security-minded person, I know we can do better. In today's ecosystem, MFA is basically table stakes. I wonder how many of you use MFA for your apps on your phone, Google Auth, Face ID, but then you choose not to if you're a maintainer of a Java package. MFA can be a few seconds of proactive security pain that makes the world's data more secure, and it should be used on GitHub, NPM accounts, Maven accounts, basically all the places you push code to and from. It might save you from a reactive security headache in the future. When your CISO comes to you and says, hey, we have a problem. That's not a good day. So I believe that humans are the first and last line of defense when it comes to an overall security maturity and the maturity of a security program. Many years ago, Bruce Schneier said in his book, Secrets and Lies, that humans often represent the weakest link in the security chain. I think in today's society, this really rings true. To continue the thought, in 1999, Eric Raymond said, given enough eyeballs, all bugs are shallow, meaning that if enough people are looking at open source code and maintaining it, surely they will find all the issues, bugs, and vulnerabilities. Really? Do you think it works? So this next one, in January 2021, it was discovered that sudo, common utility installed on just about every Linux distribution, has a serious security vulnerability that could allow unauthenticated root privileges on a vulnerable host using the default sudo configuration. Why is this important? Well, the vulnerability was hiding in plain sight for a decade. And it's things like this that confuse security teams, like how many eyeballs had seen this? Maybe it was there for a reason, right? Who knows? As you can start to see, software supply chain risk might affect everyone. Software is everywhere, so can anyone really deny being a part of the open source ecosystem? Consumers, contributors, maintainers. We all live in a world where 90% of the code used in the applications we all use is made up of open source components. We may be taking it for granted. Since open source registries are open in their nature and allow developers to openly push their packages to them, we have become accustomed to opening an issue in a project's source code repository and asking for help, asking for a feature, or just simply reporting bugs. We import open source libraries to our projects and we treat them as if they are unbreakable truths that will live forever in cyberspace. But are they really forever? Another example, history shows us that this is not the case. In 2016, a developer was in a legal dispute and deleted 11 lines of code, a little snippet called leftpad. It broke many of the largest, most widely used NPM packages for a couple of hours. Most recently, another disgruntled developer corrupted the colors and fakers NPM libraries and caused them to break and only loop gibberish. Colors receives over 20 million weekly downloads with 19,000 projects relying on it, and faker receives 2.8 million per week and supports 2,500 projects. 11 lines of code can affect all of that. I think all this shows this is a tightly woven software supply chain, and with all these examples and associated risk we have discussed, you can see why Gartner predicts that 45% of organizations will experience a software supply chain attack by 2025. Attackers know that they can attack once and infiltrate many. So are we forever doomed by these risks? I think it depends on all of us. And I think we have to know some answers to the following questions before we can answer that. And are we going to have less or more software in the future? And are we going to use less or more open source software? And so now you know, it's up to us. So who do we trust? And I'm Steve Kinman, the field CISO at Snyk. We build a developer-first security platform that helps developers build securely, even with open source. So thanks for joining today. And Jeff, what's next?
Hey, Steve, thanks for that great presentation. I think the real world use cases resonated with me. Thanks for sprinkling those in throughout the talk. I think there are a couple of things that came to mind for me. Was one, eye-opening number is 90% of, you said 90% of applications are using open source software. That's the amount that's out there right now. And that's kind of like staggering if you think about it. And I know from my personal experience, I used to use NPM a lot, and it's amazing. If you build a small little web app, or if you're using a framework, how many NPM packages you need to run it. So I think one thing, and I'd like to get your thoughts on this, is you mentioned security hygiene, and what I thought of was, that's discipline really, which I think is a big part of, mitigating software supply chain risks. Can you elaborate on that a little bit? I know you mentioned, something like using two-factor authentication. Any other ideas of how, from the CISO view, how you could, mitigate risks in the supply chain through security hygiene and discipline?
Yeah, I think it does start with, just like everything, it starts with identity and access management. You have to really understand who has access and who's using the systems, and make sure that they're allowed to be using the systems. With so many places to have an attack during that supply chain, If someone can get in and move laterally, then you're on a chase, right, from the security side, and it's reactive. So I think by proactively putting in multi-factor authentication, strong passwords, good secret control, and things like that during that pipeline and that chain, you can really stop some of those attack access points or protect them earlier. I think the other thing is, with some of the recent events, it's all about vulnerabilities and things that have been in the world for a while. And a lot of folks accept the risk of these vulnerabilities. So I think it's not about finding vulnerabilities anymore, it's about remediating. And I think that's where the focus has to switch to as part of that hygiene, is remediation of those legacy vulnerabilities that have been around for years. And maybe teams just draw a line in the sand and say, from today forward, we're not going to use vulnerable software or build vulnerable software anymore or put it in production. And then you can kind of reactively go clean up what you already have in place. But I think it's if you look at NIST 800-53 or any of the many frameworks that are in use, it's a layered approach. And the more layers you can add and that you have the ability to add as a security program or team, the better off you will be when it comes to that overall hygiene picture.
Yeah, great. Thank you. Yeah, so a layered approach. That's interesting. You can go from, and I think of as a developer in my former life, I think of, what can you do to mitigate risks in like Visual Studio, for example. And, things like make sure you scan your code before you check it in, or scan for, vulnerabilities in your package management system, that sort of thing. I did have one comment that was kind of funny. Was Doug Reynolds says, this is clearly the fault of Java and NPM, especially if you look at the graph that you showed. And he says, I was kind of joking, but it's a clear issue when maintaining JavaScript applications, which I think we just spoke to, specifically with when I discussed, being a former web developer and using NPM and seeing just, seeing like hundreds of packages come in when you're using a framework, and dependencies and that sort of thing. Yeah, so great comment, Doug. Thanks. I think one thing I'd like to mention is part of this, and you mentioned NIST 800, is I think you see, how does this fit in with like threat modeling, risk assessment type stuff? To me, that seems like a logical first step, is when you do some good threat modeling, risk management, that might help establish, known packages that your application might use, that you could look out for, when it goes through the supply chain. Another thing, when I think of supply chain, and I'd like to get your opinion on this, and this is a big one with a lot of our customers now here at the SEI, is the software bill of materials. And I would think, something like NPM would produce an SBOM with a lot of entries. Do you have any experience or any thoughts on using an SBOM in your application?
Yeah, I think SBOM is, from a security point of view, so I know that a lot of developers and developer teams are pushing back on SBOMs a little bit, but from a security standpoint, it's probably the most important maybe requirement coming, because it helps a security team know what they're trying to protect. And that's always been one of my biggest challenges, and I say it all the time, is visibility from a security standpoint. And that is literally why we scoped out the developer environment to be regulatory compliant in some of my previous roles. First, the regulatory framework allowed us to do that. And second, because we didn't know what was in there, right? So you just wanted to kind of say only certain people have access, and we don't want to look behind that curtain. And so now that we have to look behind that curtain with things like NIST 800-161, I think is what it is the new one, which will be put into FedRAMP and some of the other regulatory requirements. You now have to look behind that curtain, and you have to start somewhere. And if you go to development teams and say, what do you build? How do you build? How many dependencies are in use? They scratch their head. Are we affected by Log4Shell? They scratch their head. And I think that SBOM will be super important in helping security teams and developer teams understand where the risk is present, like you mentioned, use a risk-based framework to figure out how to prioritize remediation and those things, that's a great starting point. So I'm on team SBOM. I don't think it's the silver bullet that will solve everything. I think with a bit of innovation and some notifications and things like that, over the course of time, it will become a very well used and important piece of a security program.
Great, thank you. Again, Steve, thanks so much for joining us today. Steve Kinman, the field CISO at Sneak. Great presentation. We are going to be heading to a break here for 10 minutes. And we come back, we will be talking to Nikki Robinson from IBM. Thank you.
So the software factory is not a new term. That came about 1971-ish, like when we are building up our softwares, when we are writing a code. So Software factory is going to help us, or as a concept, as an umbrella, and we may use the multiple pipelines. Right here, we have a multiple pipelines that we can edit, so we can produce a software, or we can produce a system. So let's a little bit open up here. Just going to come back shortly. So you may have software factory here. So you may have various software delivered environment. You may call as a DevSecOps environment. Let's make it a little bit shorter so we can make the graph better. We may have a DevSecOps environment here. We may have another DevSecOps environment here, and then here. Because each of this pipeline that you are building has a specific requirements for the system, maybe the components that you are building. Maybe you are building some of API here. You may have some other complete system probably you're building. So the combination of the multiple pipelines is constructed and building a software factory. So software factory will help us use the same practices. This is important. We're using the same practices, same process. Like process are, we have to check in, check out, we have to connect it, we have to create an issue tracking, we have to create a case, we have to create a commit message. These are the more about practices and process. But however, we may be using a different tools to establish that, because DevSecOps pipeline sometimes depends on technology we are using. Like one example, C++ build process is different than packaging a Java code. You need a different type of build agents to build up the C++ code versus packaging about the Java libraries, differences. So still we are building a software, but because of the component has a different needs, we may have a different pipeline. So software factory consists of multiple pipelines, but enabling using the same practices and same process as an organization we can do. One quick example, going back to the first question again, because it's hurting us. It's hurting us specifically. If I don't have a good practice of getting the libraries, it is more organizational policies, more organization practices. As an organization, we should help or guide the developer pull the libraries properly from open source, or manage the artifact catalog in organization. We can use it over and over again in the pipeline, which is a practice. Or if I'm writing any type of stories, it doesn't matter what type of tool you might be using it, think about the security knowledge at the beginning, and then organizational policies, organization practices. So software factory is the combination of multiple pipelines, and letting us use the same process and practices, we can deliver an applications, or we can deliver apps as a result of these combinations. So single DevSecOps pipeline is not. One quick example here before going to the next question. Like AWS or Amazon, they have hundreds of pipelines. Hundreds of pipelines. They design the pipeline for a specific needs. Maybe they're creating one of the microservices, they might be creating the pipeline. So technically, like Google or Amazon, there's a typical software factory they are talking, building a software. But say they're using the same practice. If you look at that, Google has a good software engineering practices everybody's following. It is not a wild west, everybody can do different things. No. Use the same practices, process and practices, we can deliver that. Actually, a definition of DevOps is also a set of principles and practices that enable Dev and Ops, including other stakeholders. This is a quick definition. It's going to tell us again, set of practices and process, such as continuous integration, such as continuous delivery, such as continuous feedback, IAC. These are the common principles.
Welcome back, everybody. Thanks again for joining us for DevSecOps Days. I am Jeff Hammond, a DevSecOps engineer at the Software Engineering Institute. Very happy to be introducing our next speaker, Dr. Nikki Robinson. Currently, Dr. Robinson is a security architect at IBM, as well as being an adjunct professor at Capital Technology University. And she also holds a PhD in cybersecurity. She's going to be discussing chaos engineering. So without further delay, Dr. Robinson, please, the floor is yours. Thank you.
Awesome. Thank you, Jeff. Hi, everyone. Thank you so much for having me today. This is one of my favorite topics to sort of talk about. I started researching chaos security engineering just about a year and a half ago, and I see how impactful this can be. So let's go ahead and get started. A quick disclaimer: all thoughts, feelings, beliefs, everything are my own. They do not reflect any of my employers. So as Jeff mentioned, I'm a security architect by day, adjunct professor by night, also a recent ICIT fellow. I also co-host the Resilient Cyber podcast, where we get to talk about all the fun cyber things. I have a DSC in cybersecurity, as well as just finishing up a PhD in human factors. Doing the research with the DSC and the PhD really changed the way that I feel about cybersecurity in general, but specifically with human factors and finding chaos engineering and security chaos engineering really changed the way that I think that we can integrate security, specifically through chaos. So I'm going to give a quick, sort of a brief overview of DevSecOps, and then just to sort of lay that foundation for where chaos engineering and chaos security engineering fit in. And then really going through this hypothesis-based testing, the benefits of actually using a CSE program or integrating a CSE program into your own development cycles and programs. And then as well as some open source information, because would want to make sure that I give some good tools and resources to get more information on this. So not a secret here, but DevSecOps, this is really this foundational idea of integrating developer security and operations. With DevOps, you've sort of got this this integration of developers and operations groups really starting to speak the same language. And then with DevSecOps, you're integrating security into that conversation so that security engineers, developers at any sort of stage in the product lifecycle, can really start to have those conversations about where does security fit into this, instead of waiting until the end of a product when it's getting ready to go to production and trying to integrate security at the end. And especially if you're in the public sector, there's so many challenges around integrating controls and making sure that security is at the appropriate level for whatever organization or institution that you might work in. So whether you're trying to follow NIST or SOC 2 or ISO, whatever controls you're trying to fit yourself into or comply with, it can be really difficult to integrate those at the end. It can also be really difficult at the end if you find major problems that maybe could have been addressed at the beginning or part of the architecture and design process. So when I started looking into DevOps, DevSecOps, especially from the security architect and researcher sort of perspective, I had this idea of, well, how do we have this, how do we integrate this continuous iteration of security where we can meet developers and operations groups to help them, instead of impacting negatively, how can we positively impact and help developers in operations groups before, during that creation of whatever product application that we might be building. So, so chaos engineering. So this idea, really came out of Netflix and a couple of the other sort of big organizations, and it's pretty well commonly talked about now. But chaos engineering is this idea of how do we use a hypothesis-based approach to testing, to iterating. If I break something, how can I fix it? How do I add resiliency into what I'm doing? There's this great book, Chaos Engineering. It's by Casey Rosenthal and Nora Jones, in case you'd like to read a lot more about it. But so this idea of chaos engineering, which as a researcher really piqued my interest, because if we're using this iterative scientific method-based approach to breaking and fixing or identifying potential problems before products go live, or even after they're live, identifying them before a customer or a user does. If we can identify it internally and fix it really quickly, it really speaks to that iterative approach of a DevSecOps or a DevOps program. And so from the academic side, I love the idea of building a hypothesis, and sort of this is the idea of any sort of academic research. I don't ever expect to have all the answers or even find all the answers when I have a hypothesis or I want to test something or conduct an experiment. But if I conduct that experiment and I find that I'm wrong, it's almost more interesting, especially when it comes to technology, because if I, as a security engineer, hypothesize that, well, if I change this setting, this application will go down, this one setting will break the application, and I change that setting and I find that, oh, I didn't break the application. Well, what happened? Did something else break? Did some other piece of functionality break? And so you go through this approach of, this iterative, let me adapt my hypothesis and see if, even though I was wrong the first time, maybe I'll be right the second time or the third time. And I think that's the most exciting thing about research is you never know if you're going to be right or wrong. And it always leads to more interesting questions and trying to understand where resiliency needs to be built into the application or into the system. And I say that it's similar to penetration testing in the way that, like, the pen testing methodology is very much, I want to try something, and if it doesn't work, I want to try something else, and I want to try something else. So you want to continue to understand what's going on with your system instead of saying, okay, yep, we've reached the end of the sprint, everything looks fine, let's keep going. And instead of doing that, in the next sprint, you say, this hypothesis didn't work out, I want to test this one next time and see what happens. So it's this this really nice approach to continuously checking settings and configurations and dependencies. So add chaos security engineering. When you're building this hypothesis, this trying to understand how will this setting impact my application, a really important component of that is understanding what your steady state or what your current environment looks like. So what do I have right now? What's working right now? What's not working right now? What is expected behavior? Which is something that we look for in research too, is what's my expected sort of outcome? And then using this idea of the steady state, I think of it as like, what security baselines am I expecting to see? Are the configurations similar across the environment, across systems? If I look at system A and then system X, am I going to find the same things? Are we using a proper baseline? Is that baseline working properly? Yeah, it's one of those things that in continuous monitoring and incident response, it's one of those things that I've seen before where you're reacting to something and you're looking for, well, what happened? Why did the system go down? And when you start investigating, sometimes you see that, 20 systems that are supposed to be built from the same baseline, maybe there's a problem with one server and, it didn't get the baseline, but it was just sort of a one-off and it had to be done quickly. But maybe it doesn't have all the security configuration settings that I would expect to see. So seeing these sort of misconfigurations, and that's where you build that hypothesis, right? I believe that if this server is not based on this baseline or is not built on this baseline, that X will occur, that it could affect the application negatively, an incident could occur, full system compromise could take place depending on what vulnerabilities exist on this system. So it's this way to capture currently what you have and maybe identify some of those problems early on, and then take that steady state and build your hypotheses and your what you think might happen after that. And then real world events, this is based in what really happens. No application works all the time. No system is fully functional all the time. We anticipate cyber attacks and threats, and especially from a sort of an incident response area, I expect that systems will be compromised at some point. So it's helpful to sort of take this, sort of this known idea of, yes, we may become breached or we may get breached in the future, and apply that into your hypothesis-based testing. With the idea that you would essentially be conducting experiments in production. Now, when you're thinking about building a chaos security engineering program, you're probably not going to be testing all of your hypotheses in production right away, especially if you're trying to get buy-in from leadership. That can be one of the challenging things here is, I want to hire chaos engineers. And by the way, I also want to hire chaos security engineers. So to sort of get that buy-in, you can show the impact of a hypothesis and iterative based approach in dev. You can use some of your dev systems, still have those hypotheses and see what happens. And then you can show the value of finding potential issues early on, and how that can build resiliency into your production systems. Because if your dev systems are pretty close to production, which hopefully they are, you can conduct those experiments and potentially find issues before they get to production, or even anticipate what might happen in production. So you're getting away from this reactive sort of security area into this proactive approach where hopefully I'm finding things before somebody else does. And then ultimately with the goal of automating. There are a lot of really great chaos engineering tools out there and some chaos security engineering tools out there as well. There's the book by Aaron Reinhart and Kelly Shortridge, the Security Chaos Engineering, which again, I highly recommend reading, to get more information on sort of this idea, but with the goal of automating this process. It may be manual up front as you're sort of building that steady state and figuring out what you actually need to test and why, but with the idea that you can automate some of these tests and make sure that it, just like in any continuous monitoring vulnerability management program, that I'm constantly making sure that I'm expecting to see what I'm getting. So to go a little bit deeper into, as a researcher, I'd be remiss if I didn't talk a little bit more about hypothesis-based testing. One of the reasons why I think this is so effective, specifically in integrating into DevOps or DevSecOps programs, is that you start to really look at things, based in the scientific method. Confirmation bias. What do I expect versus what am I actually seeing? So you can really limit, sort of what my expectations are and what my perceptions are versus what I'm actually seeing and what's actually going on in the system. It can be really difficult. I can say this too, it can be really difficult to remove bias when you're trying to do hypothesis-based testing. So it helps if you have people that you can bounce ideas off of and sort of get feedback on that. Environmental factors. So you actually get to build hypotheses based around what are you doing specifically. It doesn't have to be this big, broad, painting with a big, broad brush. You can very specifically create hypotheses that make sense to you and your organization. It doesn't have to be, it's not a general framework. It's not a general policy or compliance. It's very specific testing which can be done. Causation versus correlation. So it can help you determine what actually caused this. So not just, I believe this to be true, but I know this to be true. This caused this other thing to happen. Variable A affected variable B in this way, versus correlation. So these two items are correlated because of X, Y, and Z. So you start to break down what's actually happening. What are the relationships between dependencies and libraries and the different coding methods that you're using. So you can start to break down where issues might occur or could occur in the future. And defining those variables, that helps a lot too. It's sort of like when you're conducting research and you identify and define your general and specific problem statement. How do I know what the problem is? And that's how you get to your hypotheses. And then you can anchor your experiments. You can really anchor them in something scientific and really concrete, so that you're not, sort of testing or thinking about something in a very, general way. You're getting really specific and technical into what hypotheses you believe to be true. So I believe that the integration of chaos security engineering, even though for a lot of teams it may not be applicable today, right now in this moment, there's a lot of value to even integrating some of the ideas behind, a full-fledged chaos security engineering program that can help mature a DevSecOps program. If you're sort of in this place where you're already integrating security engineers and security assessors into your product development and application development, you can apply some of these more general principles into what you're already doing without, having to hire too many new people or completely change your program or ask for more budget. You can slowly integrate some of these things without getting too crazy. The most important one I want to highlight here, what skills and characteristics do your developers have? I think it's the same sort of conversation we have around security. What sort of skills do your security engineers or architects have? Plenty of developers have this, I would say most probably have this, natural curiosity and inclination to try and test things. And just bringing in a little bit more of a structured way of doing it with very specific hypothesis testing and cataloging. So really logging what you're doing, what you're testing, and what happened. So keeping that sort of that research diary about what happened and why. You may have developers that are really interested in trying this. So it's good to, if you are a developer, to maybe talk to leadership about it and say, hey, I'm thinking about trying this new approach. What do you think? Or if you are a leader or a manager or, C-suite, thinking about, let me see if I can pinpoint people who have an interest or skills that may be applicable here. What's the ultimate goal of the project? I think this is, this is one of those pieces of a DevSecOps program that really should be, of course, defined from the beginning, and it's going to be different depending on the application or the project. But really understanding, I'm sure I'm like speaking to everybody who's ever done any sort of application development, or the understanding the requirements up front are so essential to making sure that as the project progresses, whether it's a full-blown application development or integrating functionality, really having those goals and requirements defined. And if you can include in that process, hey, we want to do some, spend a day of our sprint cycle on hypothesis-based testing, you can integrate that into your project schedule without it impacting, too much into the development side, but you're building resiliency in upfront, which is really helpful. And thinking about, okay, if I don't have these skills on the team, who can we upskill, or who might be interested in, sort of taking this research methodology, this research approach to what we're doing in our DevSecOps program. It's one of the reasons why, as a practitioner, so my background is IT operations, and my undergrad was software engineering, so I did some development early on. And moving into the security side, it can be, it's really helpful to understand sort of what you're working with your team, who's interested in what, adding research and academic sort of ideas into what you're doing can be really, really helpful. So there's a possibility that you may want to hire a researcher or someone who likes to do research into your program. They may be able to help build this chaos security engineering program with the developers, or someone who's a developer that's also into research as well. And And then once you have this program in place, security and development, it's not this snapshot in time. It's going to continue to change, and it changes for lots of different reasons, for the type of technology that we're using, for updates and patches, for 0 days that are released, for frameworks and guidance that we must follow or we have to, based on our customer requirements. So when you think about integrating these sort of chaos security engineering principles into a DevSecOps program, it's important to have that sort of flexibility with, that's why I say sprinkle in a little chaos. It's okay to be a little bit flexible, and we need this space, especially as developers or as people who are security engineers who are sort of getting on this project, to have that flexibility to test things. So it's about, in a little way, it is sort of changing the culture, right? That it's okay to break things. Sometimes I know I learn the most when I break something and then I have to fix it. So it's this idea of not being afraid to test things and break things, but in a logical way. You're not just testing things willy-nilly, which is why I think and willy-nilly is a technical term, by the way. But instead of taking this the word chaos and thinking that it's just this chaotic process, what you're really trying to do is build this idea of research into your program. So, but also with a little flexibility. You gotta allow for some flexibility. Hypothesis-based testing, you might be wrong 90% of the time, but the 10% that you're right, you could really find some major flaws in the application, or something that could be potentially detrimental to your customers or your users, and ultimately the bottom line. And if you can measure how those changes or those potential issues would impact the bottom line or impact production, that can really help management and the business to understand what's going on. So overall benefits, there are a number, and again, I would highly recommend looking at any of the references that I included, as well as the Security Chaos Engineering book that I mentioned, just to get some idea of case studies and things like that. But you can really integrate more security engineering skills and different types of skills. This understanding the scientific method into what we're doing into the team. I think, especially with DevSecOps, it's one of those things that we've seen that the more that we collaborate, the more that we communicate and try to understand each other from day one, it really only helps the projects that we're working on. So I highly recommend, just even talking to other security engineers, just getting an idea of what they think, talking to other people who've already integrated chaos engineering or security chaos engineering programs, and see how it worked for them. You can really improve the reputation. I want to highlight this because you can really improve the reputation of your products. If you can really, over time, continue to find these potential issues before anything happens, you add reliability, resiliency into your application. Security is not a point in time. I mentioned that. This integrating a chaos security engineering program allows you to measure the moving needle. So the moving needle of security, however that's changing, if it's technology, people, or process, you can help to identify and work on those problems ahead of time before they become an issue. And ultimately with the goal of reducing cost of security, right? If we can lower the amount of cost that's associated with security, it's beneficial for everyone. Of course, it's great for leadership, right? We can show that we can still integrate and implement secure practices into what we're doing on a project without, increasing budget, at an insane scale. In this method, you're not just relying on tools and processes. You're really using a hypothesis scientific-based approach, which really adds validity and reliability to what you're doing. So, integrating this into your program, you can feel free to use those words, reliability and validity, just like we do in the academic world, to help prove that what we're doing is helpful and valid and important. And then again, getting you to that predictive area. You're not just sitting and waiting for something to break or waiting for someone to report to you that something's broken. You're actively trying to find what's going on in your application ahead of time. So really trying to predict what might happen and resolve it before it ever becomes an issue. I would be remiss, I'll spend 1 minute on this, but I would be remiss if I didn't mention vulnerability chaining here. This is one of those things that should be part of the hypothesis-based testing. So the idea of taking multiple vulnerabilities that could be used in combination, you can use that in your hypothesis-based testing in your security chaos engineering program to understand how vulnerabilities might be used together. So you can hypothesize, you can test them, and then ultimately you can potentially fix them if you find that they might be an issue. So understanding where your known knowns are versus your unknown unknowns. So getting to a place where you're sort of predicting what vulnerabilities might exist in the environment from the security side. And then open source information. I just wanted to include this really quickly for anyone who wants some additional references and tools. Chaos Slinger was actually developed by Aaron Reinhardt, who also wrote the book. So feel free to take any of those references. There's a lot of great information out there. But yeah, just make sure you check your sources. There's some really great stuff out there. And that's it for me. Thank you so much again. And I think if we have a couple minutes, time for questions.
Again, Dr. Nikki Robinson, a security architect at IBM. Thanks so much for that great presentation. I think we only have a couple minutes left. And I jotted down a few notes here. One question I wanted to ask, and I think you addressed it kind of throughout the presentation, but I thought was interesting, is the concept of getting buy-in for hypothesis-based testing. Can you recommend some methods for getting that buy-in from an engineering team?
Yes, definitely. So, what I would recommend is looking at some of the use cases that already exist in the world of chaos engineering. There's some use cases for, obviously, for Netflix and some of the other big companies that are pushing out, I don't even know how many how many changes a day to production. So looking at some of these use cases. And then I would also suggest for getting buy-in, just genuinely try it. Like try one hypothesis and see what happens. You know, you can come up with, if you get the book, there are some ideas in there for things that you can test, but you can also find a lot of open source information for things that you can test in your CI/CD pipeline to see how things might work. So I think that would be probably the biggest suggestion I would have, is start with your CI/CD pipeline.
Okay, great. So that's getting the buy-in. Then that's a good segue to the next point I thought, was interesting, is you need a specific level or a certain level of maturity, I guess would be on a case-by-case basis before you start to sprinkle in a little chaos. And I was wondering, what's a good place to start? And I think you just answered that. It could be one use case, or starting with something in a CI/CD pipeline. Is that accurate?
Yeah, definitely. And I would also say, if you're more interested in the security side of it too, especially with things like we've had with the Log4Shell and the all the other attacks that we've had recently with the software supply chain, I would recommend taking some of those thoughts, right? Like, how were those attacks conducted, and trying to hypothesize how that might impact your own specific environment. So thinking about, what is one dependency that you use that you think maybe it would be unreliable in this circumstance. So taking something very specific, but based on, known threats, known attacks. So that way you can slowly start to understand how that might impact your own environment.
Thank you. I think that's about all the time we have. Again, thanks, Dr. Robinson, for joining us today.
Yeah, thanks for having me.
Great. Great presentation. So we're going to take a 30-minute break. And when we return, we're going to have another keynote from Bryan Finster. And it's going to be about how to misuse and abuse DORA metrics. So we'll see you back here in 30 minutes. Thank you.
Oh, that's a good one. Actually, I'm going to give an example from my son. So he just this year he was in the 9th grade, actually 10th grade, and he's doing more about the Python learning. So high schools, it's a good opportunity to let the people explore what the programming that we discuss, what the contexts are. So high schoolers, and I really advise that, enable the students to see how they are capable to use a new building of the code and how we can write the code. Actually, and I give the analogy as well, like we are in the digital native right now because most of the kids, most of the students are learning or exposing the digital environment day number one when they go to the schools. Like they can use the ecosystem such as mobile devices, they can use the tablet, they can use the laptop, they can use everything as a computer. So the high school, they should really give an opportunity how this system is working behind the scene. How can I make sure that the students are learning, basically collaborating with the Google Doc as an example, maybe writing a script on Excel file as the macro, maybe writing a basic script of get their job done. So like building the concept of how it is going to work, and I can really get the students be ready of understanding the reason behind it, understanding the cloud, understanding the operating systems, understanding the basic coding. And basically, like you can use the Python code as my son, he used it this year, writing a Python code and start to build up a specific example or the application for them, you can learn. So when we go into the higher level and the college level, we also think about how can I make sure that I'm building a software system eventually will be used in the bigger context. So in the college, we always teach about the algorithms, databases, and other components, which it is good to have it. We should have it. No question about it. We need to understand the fundamentals. We need to understand how things are going to work out, what the best algorithms are. How can I really use the better memory? How can I communicate in a short messaging system? So we can learn that the college level, but at the same time, we have to tie ourselves how it's going to use in the industry practice. We should connect ourselves more about experience, more about trying something. I always encourage the students, if you're in high school, try to build up something for yourself. Maybe you just can automate your document sending to your teacher. Like try to automate that if you can. Maybe you're writing a basic PowerPoint, try to write a basic macro in your PowerPoint and try to automate some of the visualization and graphics in your PowerPoint, which is doable. So think about how can I look, it's going to tell you to start some knowledge of the scripting. So when you go to the high school, the college, now you're going to get, how can I build up something that I can use and using my GitHub environment, open up a space in the GitHub, try to expose more realistic scenarios, more realistic example. So what we are learning, we can apply in the real world scenarios. I see a disconnect between, because even though my students, I saw sometimes they know the fundamentals, but it's not as realistic in the real world scenarios. How can we manage that? How can I manage the users? How can I manage some complexity? How can I manage basic writing code versus writing on desktop or sharing somebody else? It is more about experience. So I want them to think about out of box, think about how can they use different contexts, more realistic. When they go into the more realistic example, they will learn how to build up the software. They will learn how can I speed up the pipeline, which goes back to software factors. They will learn how can I reuse my code over and over again, because they're going to write the code. They will see the similar code again, and they will think about how can I make it a little bit modular of my code that I can reuse again in the futures. So this is basically going that direction. And then in low code, no code, one of the part in the questions, it's more about the reusable of existing application for over and over again without writing so much code. And most of the, even though sometimes we use that, we're not writing the code, but using a shared as an example. We're using other ready solutions as either drag and drop or connecting dots without writing much code, but just reconfiguring an application to serve our needs. That's going to help us. So most of the students are already using that directions.
Another great answer, Hassan. Thank you for that. We've got a good question in the chat from Rajiv asking, how does container technology change DevSecOps?
All right, that's another good question again. Love that discussion. So let's talk about what the container means, so we can maybe come back to DevSecOps a little bit. So I think that let's go this way. Like DevSecOps is a set of practices and principles for us. We are building continuous integration, continuous delivery, continuous feedback, all this continuous term in the DevSecOps practices. So what the container is, as the little bit background, container is giving a process and isolated from operating system for serving a specific need. So it's basically specific to the app content and isolated from others. I have an app 1 here. I may have an app 2 here. Both are isolated to each other's. I can do that. So going back to the continuous integration, as we said, we would like to automate a build as fast, as quick as possible. And also we would like to deploy without changing much in the production environment. So automation and deployment are the key element is helping us make it a containerized applications. If my application is more container, more isolated others in a small size of the Docker file or the specific features, then I can automate the build and I can deploy without affecting others. So in this context, is really helping to speed up delivery, speed up testing, speed up automation. Because I can stand up a different test harnesses for this container separate, this container separate. I can run 2 of them in the same environment. None of them is going to be interacting each other as they're using different, maybe using a different libraries, different versions, same libraries. It's going to help us to deploy quickly. So how can we use this container? I think we should discuss a little bit more as well. It's about architecture element. As we said at the beginning, so you may be creating a one service as an application 1. It may be one of the microservice that you may be writing here. So because you are getting more specific to the service and how application 1 or app 1 is communicating with others. Same thing for A2 and communicate others. So you may be writing a microservices. So microservices is the way of architecting. You are packaging your services in the container so you can push into your pipeline. So like pipeline is we established, now we are adding an architecture components of the system that we are building and packaging as a container and calling as a services. That's the relationship. I can deploy it. Maybe one of the messaging services that I may have, maybe some of them are payment related, some of them are report, and some of them has puzzle maybe sending some message to other components. Some of them is just a database communication. So it depends on the service type. And we are packaging the service and put in the container and then ship into the production or deliver into the staging environment. So it is helping the DevSecOps go much faster by using continuous integration, continuous practices. If we don't have a container, yes, we can do the same DevSecOps practices, but we have to write a test automation. We have to write deployment packages. Maybe have to write different build packages. Maybe have a multiple pipeline we set it up. So in that connectivity, it is helping to go much faster in the context. But it is important to make sure that we are writing the right container files to meet our needs. But we don't want to creating a container file that's about the 1 gigabyte size. It's not going to help. So make sure that you are following the best practices, how to make sure that we have a right layer architecture in the containers. How can we write a very minimal size of the containers? We can go fast in the DevSecOps deployment and test cases. So we can enable the reusable of the components in the libraries that we have the layers of the container. We can use that. It is really important to make sure that we have a right container architecture that we are following and we can use over and over again. Because otherwise, put everything in one container, make it a 5 gigabyte size, it is not going to serve the needs of the DevOps perspective. It will be late to deploy. It's going to be problematic to deploy into the production environment. So when I really give what really DevOps means, there is four fundamental principles of DevOps. And one is the collaborations that we do. And the second one is the infrastructure as code. We kind of call it the IAC. And third one is automation. And fourth one is about the monitoring. So this is kind of like more about the common principles that we were talking. I know there are dependencies. So what really means this core component for us? I know people heard about the culture as one of the elements. I kind of give the analogy of building up a DevOps is, think about that you are really driving a car on a highway. Like you just go fast as much as you can in a highway, but you were looking for a good highway, right? If you don't have a great highway, no matter what type of car that you have, no matter what type of brand that you have, you cannot go as fast as you can. So let's think about this analogy in here and take a look at perspective. So we need a highway, we said, right? We had a really good road. In this road, we can drive car fast. So what means in the software world, we would like to really build up the code, we deliver as fast as we can, and end of the day, we can safely arrive our production environment, which is our destination, right? We would like to go into production at our destination. To achieve this road, it's really requiring to build up a great infrastructures. It is important to build up a right infrastructure, which is give us a ability to automate and give us a repeat the same environment over and over and again. It's going to give a high degree of assurances that we don't have any intruders that go into the road, so kind of block that, which goes back to the S1 that we discussed. So we can really block anybody goes into the highway, which is kind of build a highway. And how are we going to build up the highway? We have to understand our team, which goes back to the collaborations. Like teams are, people are going to use this environment. People as us, like a users, right? We would like to use this highway. We would like to use the application that we are building. We have to really collaborate with the team to build this infrastructure. At the same time, we can use effectively with this infrastructure, requiring the stakeholders. So collaboration is all about the stakeholders, and the stakeholder has a visibility or has to say something in the software lifecycle that we are looking for. So let's look at the other two elements with automation and the monitoring perspective. Let's build up the highway. Teams are agreed on it, and we have drivers, we have users, we have developers, we have architect. Everybody is kind of a part of that, our discussion, our team. Even though we have cops on the road, which is the security people usually, right? Cops are looking for anybody goes high speed or anything else, we can trap it. Same analogy in the software world, we have cops. Cops actually helping us to go as safely in our destination. So with this concept, now we would like to automate that. What we are automating is, we don't want to have, if you're going to fast on a highway, like, you have a great car, you're going to maybe, 75 miles per hour, whatever the speed limit is, because we don't want to go about the speed limit, of course. So within that condition, we would like to go as fast as we can. How can we go as fast as we can? Means we have to automate that some of the steps. What automations are? Let's say we go through the payment system, like, we have to go through the ticketing system, probably in your highway, or you may have the checkpoints in the highway. Same thing for the software world is true. We would like to go fast by building the components, by compiling, by testing, by delivering, by deploying. It's requiring a automation. So we build up IAC. Let's go a little bit layer. So we have the infrastructure as the first layer, we build it. So now we put the code and application on top of here. To make sure that it is going fast, we have to use automation in our deployments. So like we can test it, we can build it. So we have this combination, we automate the build and deployment. Now, next one is, how are we doing well? Like, how are we targeting a time goes into our production environment that we have? Production environment, or we may have other testing, or we have a staging environment that we do. So go in this things like how we are doing well in terms of how we're driving. We can improve our practices, we can improve our knowledge, we can improve, and some performance of the system is requiring a monitoring. So we have to really monitor our progress, how we are doing well through the life cycle, we can get better. And also monitoring is also loaded term. We would like to monitor how application is behaving well. And also we can collect the feedback. So feedback is from stakeholders, from our users. We can collect the feedback. We can monitor those, get into our team that we were talking about. Let's go a little bit up. So teams, it's going to be our collaborations. People would like to share that. So like fundamentally, DevOps is kind of building up a good way of building the software that we have to speed up. When we go fast, we have to use automation practices to go fast, because otherwise we cannot go fast. But to automate some of the component that we are building, there's another dimension in the DevOps, which is more architectural element. Like if you cannot really architect your system well, you cannot automate some of the practices. If you don't have, you have a great road, you have a great turnpike, you have a great the component that you build in your pipeline as your road. If you don't have a good car, that you cannot go at higher speed, which is the similar analogy. Like you need a good car, you need a good architect, you need a good component just so you can drive fast. Yes, it's a really growing topic right now, Shane, for the SBOM, especially for dependencies or open source, whatever you call about it. I think let's define what the software bill of materials means. It's basically all the software components, that is including open source, including any type of dependency in the application that you're using it, and make them as visible, make them as traceable throughout the life cycle. When we say like a traceable, it's basically we have to know what other components are we are using it, what the versions are we are using it, where we are using it. That's actually two couple of things, like what the version that we have it, and where we are using that libraries in which context, like maybe a server, maybe some of the dev, maybe some of them is a build package, some of them is runtime package. If we know that where it is we are using it, so we can be ready for any type of incident, any type of vulnerabilities it's becoming for specific vulnerability for that libraries. Because if you don't know where it is, if something happens for a specific libraries, if you don't know what we have in our infrastructure or the build process or environment, it's very difficult to find that and patch that, because we are racing against the time. And like there's a concept of the 0 day, even though the vulnerabilities exist, like identified older in the community, as an organization, if you don't patch that vulnerability timely, that given application, it is going to be a 0 day still for us. So we have to be very effective with that. How can we do this effectiveness? It's really a good software delivery environment, such as doing a good DevSecOps end-to-end, will help us identify those vulnerabilities, identify this type of libraries easily, or we can keep track that libraries throughout the life cycle. We can go and patch that. I know we're going to discuss most likely, I'm guessing it, because this is going to continue. I think we're going to see how we can build up SBOM as part of continuous integration. How can we build up the SBOM using a single source of, as an example? How can we connect the dots? So once we go to the further dive into the question, I will come back again and answer that specifically. Overall, using a good practices and end-to-end life cycle with DevOps component will definitely help us to speed up and be aware for any type of vulnerable, any type of the med dependent we are using in life cycle.
The SEI is a research organization on the cutting edge of cybersecurity and software engineering.
We are based at Carnegie Mellon University, a global research university annually rated among the best for its programs in computer science and engineering.
We serve the nation as a federally funded research and development center sponsored by the U.S. Department of Defense.
Using proven software engineering principles and practices, we serve as a national resource in software and information assurance, cybersecurity, and data modeling and analytics.
The SEI offers a diverse, inclusive environment that fosters collaboration to spark innovation.
Our employees are excited to work together to solve our nation's toughest problems.
It's an incredibly exciting time to be in the software field. Software is not only one of the biggest challenges that we face, but also where innovation lies.
The SEI is the birthplace for cybersecurity. The CERT program started in 1988.
This resulted in the establishment of the first computer emergency response team right here at CMU.
We build on a strong foundation of theoretical research by creating prototypes, conducting demonstrations and real-world pilots, developing training, publishing our findings, and delivering capabilities that organizations can use.
We are driven more by the desire to address complex, long-term problems in an innovative way rather than selling a specific product or service.
As a part of my work, I serve as a liaison between academia and the government. The motto of our center is to make the recently possible mission practical.
So one of the things I like the most about working here at the SEI is the ability to kind of choose your own adventure. You're given the freedom and flexibility to take a body of work and make it your own. Make it something that's suited to your skills and interests, and apply your unique talents and techniques to ways that can benefit the DoD.
It is also very rewarding to be a part of a world-class university in computer science and engineering like Carnegie Mellon University.
A global research university with more than 13,000 students, 100,000 alumni, and 5,000 faculty and staff.
Our community bridges the art and engineering worlds, is a world leader in robotics, and is home to one of the world's best schools of drama.
The ability to be part of this community and collaborate with the diverse research talent on campus really sets us apart.
And really, the Pittsburgh area has something to offer everyone. We have lots of arts, sports, outdoors, and I get to be a part of that here on campus.
At CMU, I have the ability to continually expand my skills in the latest cutting-edge research and technologies and use that knowledge in my work.
So one of the great benefits of working at CMU is you get to take any classes that you want completely for free.
I've been able to take advantage of the tuition benefits to continue my education while I work here at the SEI.
If you're a student looking to expand your education beyond what you can learn in school and earn money doing it, we want you to come work with us.
The interns I manage do real work, writing code, analyzing data, and collaborating as valuable team members.
As an intern, I've had a wonderful opportunity to work with many SEI experts.
I could see myself transitioning fairly easily into any sector that they would want me in.
We are at the nexus of academia, the Department of Defense, and government. Our people make this exciting. I joined for the mission, but I've stayed for the people.
I am.
I am.
I am.
I am the SEI.
We are the SEI. Come join us.
The work that we do directly impacts our nation. For more information about available career and internship opportunities with the SEI, please visit our careers website at sei.cmu.edu/careers. We hope that you'll join us.
Hi, everyone. Welcome. Today, we're going to be talking about how to misuse and abuse DORA metrics. I'm Bryan Finster, a distinguished engineer for Defense Unicorns, working as a value stream architect for the United States Air Force's Platform 1. I'm also a board advisor for the Value Stream Management Consortium. They're doing some good work there. I suggest you look them up. And I firmly believe that if we deploy more, we will absolutely sleep better. Back in 2014, in a previous organization, we had an ask from our leadership to take our very large and complex system that was deploying every quarter and find out how we could deploy it bi-weekly so we could better serve the business need. And so we started digging in and bought copies of continuous delivery to figure out how we could get that done. And, you know, we had some ideas, but we really wanted to get into the nuts and bolts. And once we started really looking into it, we said, well, why can't we release every single day? In fact, we had a little bit of pushback from this, but we were like, no, this is really the goal that we should be going after. And so we did. The first thing we did was we aligned teams to business domains. We did some domain decomposition of the capabilities we wanted to implement first. Built some team structures around that and said, okay, well, we need these teams building a loosely coupled architecture that would allow them to deploy in any sequence at any time on demand. And then we also built a CD platform team that would build the platform that the teams could consume so that the teams can construct pipelines that met their particular needs while also implementing some core capabilities for the entire area. And we had some lessons from this. I mean, the first thing was that, you know, previously we'd had a scaled Agile implementation that was just not giving us the outcomes we wanted. And what we learned was that as we start decoupling the system and letting these teams run as fast as each one of them could run, that it scaled much better and gave us much better outcomes than trying to use a process framework. Also, we learned that just the question, why can't we deliver today? Let's uncover these problems. It was really the best tool for finding the organizational issues, both within the teams and within the area that was impacting the teams, to get to where we wanted to be for that daily delivery. That as we started driving down that batch size and saying, really, why can't we get today? I mean, you know, we deployed last week. Why can't we do it every single day? It was very good at uncovering those problems and then letting us methodically go after and correct those issues. We also learned that CD absolutely improves outcomes, but more importantly, it improved morale, and that the teams that are implementing continuous delivery flow were much happier, and other teams were really looking forward to getting better at that as well. And we spent a lot of time doing education about, hey, here's what we found that works, what doesn't work, and spreading that message. We also found we needed better metrics. The things that we were measuring were not giving us what we wanted, because anytime you're measuring things that have to do with people, it changes people's behavior. And so the metrics we chose didn't change behavior in the way that we intended. So the first example of this was we knew that for continuous delivery to work well, we needed to improve how we were testing. We couldn't wait to test to the end. It had to happen integral to the flow of delivery. And so we thought, well, if we measure test coverage, then what we should see is improved testing. Now, what we actually saw was an increased number of poor tests, that we saw people doing testing sprints, delaying features to work on tests to meet a minimum number that we picked. But the tests themselves weren't very good at all, because we hadn't really focused on how to test better. We just said, test more. And so they did. And what we really should have been focusing on is the outcomes we wanted and not compliance to a number. We should have really been focusing on how do we improve deploy frequency while also improving our defect rates so that we have smaller batches of more high quality work. And doing that would have improved testing. Something else we were looking at was we were looking at completion rates. We wanted to be more predictable. And so we thought, well, if we focus on completed versus committed work, that the teams will be better at keeping those commitments. And what we really found was that it focused people on planning instead of working. That if, you know, to meet the number, they would spend a lot of time in very detailed planning to make sure the timing would fit exactly in where they wanted to for the sprint or the quarter. to meet their metric. What we really should have been focusing on, again, is outcomes. We wanted an improved flow of delivery of smaller batches of work that could be more consistently delivered so that we would be predictable. And so by trying to shrink the development cycle time and then the lead time and focusing on improving defect rates at the same time to have balance, to not drive off the rails, really would have given us better outcomes. And honestly, the very first time I went to DevOps Enterprise Summit, I was there to try to learn about metrics, to try to improve these things. So in 2017, we had an enterprise goal to expand this to all the teams, that we knew that from our experience that continuous delivery was a really effective tool for improving everything around the enterprise. And so let's just do that for everyone. And so what we did was we created a global platform that was very opinionated around continuous delivery flow, that the tool was easier to use when you were doing a continuous delivery flow, where you're using trunk-based development and continuous integration, than it would be if you're using something like GitFlow or some other legacy process that was not compatible with CD. And we also gamified our metrics. We brought in Hygeia and then started putting, kind of scores on some of these signals that, how are you doing in trunk-based development and continuous integration? How's the daily deploy coming? Are the pipelines stable? Do you have good static analysis coming in that, you're generating cleaner code and all these things? And the gamification proved to be pretty effective. What we learned is that the gamified metrics were really effective for like the first half. The people who were interested in learning about continuous delivery or just improving delivery at all, and the leading edge people were very competitive about it. They would come and challenge us all the time about how we were scoring things to try to make that better. We also learned the opinionated pipeline encouraged people who were the late adopters because it was a little bit painful to automate their process. There was a lot of hoops they would have to jump through and workarounds, all sorts of things to try to get their old bad process implemented with the CD pipeline. And so they would come to us for help. And that actually led to us creating a dojo to help teams execute continuous delivery. And actually, I wound up leading that dojo for several years. We also needed better ways to communicate why we were doing this. We knew at the CTO level, because that was the goal, is we're going to improve the enterprise with continuous delivery. That was a top-down request from the CTO. And we knew in CD platform because we'd executed this way in other areas. And the thing we didn't have good, though, was a good way to communicate to everybody else what we were trying to get done. We needed some better ways to do that. But then in 2018, Accelerate came out, and it validated what we'd learned, that continuous delivery was absolutely a good tool for improving the performance and quality of what we're delivering, and improving the organization as a whole, and improving how people felt about working here, that it was less burnout and less pain. And then it gave us a way to communicate that broadly. We literally bought 6 cases of Accelerate, handed it out globally to executive leadership and senior leadership with a flyer inside. Please read this book. This will explain what it is we're trying to get done and really help you along your path as you try to help the teams in your area. It also gave us 4 key metrics. These should be familiar with anybody who's really been focusing around here. That's lead time, deploy frequency, mean time to restore, and change fail percentage. To talk about how healthy is the system of delivery and how is it improving. And we said, look, here's these 4 key metrics we can look at. And we can also track these. And it caused a problem. What happened was that those 4 metrics really make sense in the context of the rest of the book. But you have to read the book for those 4 metrics to really make sense, because measuring behaviors is a complex problem. If you're measuring people, anything around people is going to be complex, and you have to always be inspecting and adapting and verifying that what you're doing isn't causing adverse behavior. And people didn't read the books. Some people did, and we would have really good conversations with those people, and they became really good advocates for what we were trying to do, but others didn't. The books gathered dust, and so we weren't being effective at doing the communication we needed so that they would understand how these things work. And that caused the metrics to be oversimplified, that the way we were communicating things made it sound like all we have to do is measure our way to improvement. And some people started doing that because the purpose got lost in translation, and we wound up in chaos because we'd oversimplified the problem. And this led to people using metrics in ways that absolutely should not have been. Here's an example of using metrics as goals. I've seen areas where they had OKRs for DORA metrics. And that's not what these are for. The reality is that high-performing organizations are not high-performing because they focus on the DORA metrics. High-performing organizations focused on improving the value delivery to their end users and methodically got better at that. And that any goals we have should be focused on our business outcomes and not metrics that are focused on health. They also use for productivity. Now we can find out which teams are less productive and go and figure out how to fix them. But the fact of the matter is every team has their own context, and the absolute value of the DORA metrics is very dependent on the context that team is delivering in. We should see improvement, but not try to use it to stack rank teams. But also, this is not about productivity. This is about measuring the health of the system of delivery. And if you don't have the right culture anyway, then using these metrics will be destructive to our goals. Or speed, that we need to deliver faster, so we need to have a higher deploy frequency and everything will be great. I mean, the problem is that these are not, it's not a speed metric, it's a batch size metric. The goal is not to go faster. The goal is to reduce the size of delivered batches so that we have higher quality, that's more stable, that we can recover faster when things fail, which they will. And that the reducing those batches exposes and waste that we can remove and makes things more efficient, that we get more efficient quality processes and more efficient just process in general. And doing that does improve speed, but if we just focus on the delivery frequency, we won't get speed because the quality will decrease. We also saw vanity radiators. These are dashboards people would create. And this is actually an example for a different organization, the one I was in, where it shows, look how good we are at DORA metrics. And so you can see here that deploy frequency is obviously the most important thing. But if you are really deep into continuous delivery, there's all sorts of red flags in here that aren't really apparent if you don't have a deep knowledge of it. But more troubling, how big is each one of these orgs? There's no context here. What's the time range we're looking at? You know, for the first one, is that 437 deploys in the last 2 years or last week? Don't know. And we don't know if this is better or worse or what action to take from this data. It's just, look how great we are. These metrics are health indicators. That's what they're for. We're trying to find out, are we reducing the batch size because smaller batches make things better? Are we improving our quality and reliability? Those things are incredibly important, and shrinking batch size without making those things better isn't going to be helpful. We need to track that as well. We're also trying to reduce toil, because not only does it make us more efficient, but it makes people happier not to do that. We're accelerating feedback. Are we getting the information back to the team, the product owner, or the organization to inform our business goals? And do we have happier customers? Because none of the others matter if our customers aren't getting better value. And do we have happier teams? Because if we have happier teams, we're going to have better solutions that are more stable with higher uptime, because people can focus on that instead of just trying to meet the next metric. And are there only 4 metrics? No. The continuous delivery metrics that we have here are they're for continuous delivery, but they are not a complete view of our entire organization. And they're not the only 4 metrics that DORA recommends. If you look through Accelerate, and I did briefly for this talk to prepare, that I went through and I pulled out some things I knew were in there around flow. You know, we need to improve the flow of delivery and look at where we have constraints through the organization. Continuous integration is key, because we're not going to make CD better if CI is not better. And these are metrics that are really easy for the team to control. We have to have the right culture. We need to make sure that people are happy, they want to work here. We have trust. And we need to avoid burnout. We need to make sure the customer outcomes are good. You know, it doesn't matter if we improve everything else, but the customer is unhappy. We need good information radiators, things that cause actionable motion with the data. So here we actually have an example of something we're building inside Platform 1 that we'll be open sourcing as part of our platform. On the left, we have WIP load, and we're talking about how many things do we have in progress compared to how many people do we have in the organization, or in this case, a team. Because if we have too much WIP, then there's lots of context switching going on. Nothing really gets finished. It just causes stress and burnout. Instead of us actually finishing things, as Dominica de Grandis will say, just stop starting and start finishing. On the right, we're showing how we're doing around continuous integration, because this is something that's actually we can gamify and show people this is what CI looks like, and this is how you're doing on CI, and this is what good looks like. Because if we don't show what good looks like, no one has anything to compare to say, how do we, no incentive to improve. But then it's not good enough to just say, this is what good looks like and this is where you are. That's just cruel. What we should do is provide tips for improvement that are down to earth. These are some good ways to break down work better, test better, do evolutionary coding, all these things required for continuous integration, so that teams can self-improve. And so we don't have to talk to everybody in the organization directly about how to get that done. We need to understand the relationship that these metrics have. I mean, we've talked a lot about there's more than these 4 metrics, and we need to look at all of them, but how, for what reasons? Number 1, we need to be focusing on business and customer value. That's the most important metrics we have, and we need to identify what that value is, how we're going to measure it, and track it. And we need to have goals. We need to have objectives that are with objective key results that tell us whether we're getting closer to our goals, and that those objectives are actually improving our business and customer value. Then we need flow metrics to verify that we don't have any constraints, or if we do have constraints, to figure out ways to clear them. Do we need to reorganize some of the teams in the organization? Do we need to find ways to automate things that aren't today, or fix other sorts of constraints we have? And those flow metrics are really important. And of course, continuous delivery. CD is the driver of everything that's going to make things better, and these DORA metrics are key for measuring the health of our CD processes at the team level, but they are not goals. And then that all lays on the foundation of continuous integration. These are things that the team has absolute control of, and things that we can provide tips to improve at the team level that will help improve everything else and help uncover issues with CD and flow and why we can't meet our OKRs. And with all these metrics, you need to understand how that data is being generated so that you can make the right decisions. That the CI metrics are coming from the tools themselves. They're coming from people actually making changes to code, and that data is very high fidelity. As you start moving up the stack, things get a little bit more fuzzy. Flow metrics are coming from people moving cards, and my experience has been that the quality of that data is going to be tightly tied to how useful people find moving cards to communicate work that's being done at the team level. And so we have to find ways to make sure that they understand how to use this to help themselves so that they will focus on doing it well. We should also be reporting data quality issues on this. And as you get up to the top, it gets much more abstract. I mean, profits, pretty concrete, but I mean, when you're talking about value, it becomes more abstract, and you need to understand where the data is coming from so you can make the right decisions and not just look at a number and say, oh, this number means something very concrete when it may not. You also need the right culture. You need to make sure that we have trust, because trust within the organization is the first impediment to delivery. Along with that, we need a shared mission that people care about, because we can't just hand things off to teams and expect them to deliver good results if they don't care about the mission. So we need to understand that mission and focus on it. We also need to have a culture of learning and improving so that we don't have a fear-based culture where failure is not an option. We need to make sure that failure is not something that's happening every day, but when we fail, we take the appropriate steps to learn from it and move forward, and without pointing fingers at people. We need to look at how the metrics stack up and understand that if I focus on improving flow, but I don't focus on improving continuous integration, I can only improve it is to the point at which CI becomes a constraint. And with teams not focusing on CI, that could be really, really quickly. We need to make sure that we're focusing on how to improve CI if we want to improve flow. But we also need to make sure that we're investing in our education of the teams, so the teams know how to do that and not have our business depend on hobbyists learning in their spare time how to do continuous integration and hope they find the right information to how to get it done well. We really need to invest on providing good information to them and give them the time to practice how to get better at this and all of the skills required. Metrics require balance. We need smaller batches because they uncover pain, but we also need to make sure that we are focusing on quality as a guardrail to make sure that those smaller batches aren't incentivizing people to skip quality steps. But we still need to make sure that we're getting feedback from the teams that they're working in a sustainable way, that we're not seeing a metrics improvement because they're working 16 hours a day to get it done, that we are sustainably improving. Because if we don't, we can absolutely see a metrics improvement for a short period of time, but then people get burned out and that it was all fake. It was all through heroics, and we don't want heroics. So some closing thoughts. There aren't 4 DORA metrics. Yes, there's 4 outcome metrics of continuous delivery, and continuous delivery is incredibly important, but there's more than 14 metrics in Accelerate, and I encourage everyone to actually read the book a few times because there's a lot of subtlety in there. Also, product development is a very complex interaction of people, products, and process. There are no simple metrics. I can't give you 1 or 2 metrics to tell you how things are doing. You need to go and really understand what it is you're measuring. And measures require guardrails to prevent perverse incentives. Always focus on, we're measuring this thing. Now, is there anything else going wrong? What could go wrong? And track that as well. Metrics are a critical part of any improvement toolbox, but we can't measure our way to improvement. We can use them to monitor improvement and inform our next improvement experiment, but the numbers themselves won't get us there. And don't measure people. Don't focus on individual productivity. You should only measure the lowest common level to measure is going to be the team level. If you go below that, it's going to cause destructive outcomes. I've seen it multiple times. Invest in our people because they're our most valuable asset, and the people and they are going to cause us to have success. So some resources that you can pick up, of course, Accelerate. I highly recommend Sooner, Safer, Happier by John Smart. It's a really good book to talk about patterns and anti-patterns for enterprise improvement. And then Gary Groover's Engineering the Digital Transformation is an excellent nuts and bolts guide that does a really good job of translating from manufacturing to software and talks about what's same and what's different. And gives you really good ways to methodically improve your quality process. And also, Dave Farley, one of the co-authors of Continuous Delivery, has been releasing a ton of really good content on YouTube. And I created a short link here for his YouTube channel. I recommend everybody check it out and just, spend a few days watching his videos. It's really entertaining. So help that I need, how are you measuring value? I know very well how to measure waste, but trying to measure value in a way that we can sort of indicate at the abstract level of the entire organization, the value we're delivering when it's not simple one product. I'm really interested in this, and please reach out to me afterwards, and let's have a conversation about how to do that better. And let's talk more about this. I love talking about improving. I'm very passionate about it because I know what it does for organizations, but more importantly for the people doing the work. And you can look at my Medium blog where I have the 5 minutes of simplifying DevOps. Also, I'm Bryan Finster on LinkedIn, or just email me at brian.finster@defenseunicorns.com, and let's talk about how we might be able to help. Thanks very much.
All right. Hey, thanks for the talk. Excellent talk, Bryan. Really appreciate it. There's a lot of great content in there. Hopefully we have enough time to dig into it here. Real quick, I wanted to go over a few of the questions that were asked on chat and give you a chance to address some of them live. I know you were answering some of the questions during the presentation.
Sure.
I'll let you choose which one you want to start with.
Well, I think you asked a question about my favorite metric, and I hopefully I was clear that you can't just have one metric. If you do, it's going to create perverse incentives. I think something I've seen frequently is, for example, the DORA metrics. Someone will implement DORA metrics and say, okay, we're going to increase deploy frequency. Well, I mean, the outcome of that is that you're going to deploy more frequently, but you'll also put pressure on teams to skip steps to get that done because they're being held accountable to how often they're deploying. And then you'll see that result in defect rates. So you really need to measure defect rates at the same time. And of course, you also need to be focusing on, is the team itself healthy? Are the people getting burned out, working like super long hours, or just performing heroics to get that done? And how do we track that as well? You need to, keep those things in balance so that any improvement you get is real improvement and not just temporary fake improvement.
Yeah. So, one of the things I was hoping you could talk a little bit about, something that was in your bio, your overview. You say, deploy more and sleep better.
Yes.
And I think that's a really important point, isn't it? Why are we doing these things, and what are the outcomes?
I mean, my background, I've been a software engineer for nearly 3 decades now, and most of that time I've spent supporting business critical enterprise systems that 24/7 high availability, and a lot of that time doing it wrong. And the story I told at the beginning of this talk were the outcomes we experienced where we deployed more frequently with higher quality, higher morale. We had fewer incidents, I started the DevOps dojo at Walmart to help other teams learn how to do these things. It was, part of platform there. And that was our motto, was deploy more, sleep better. Because everybody on the team, we were all engineers who'd worked this way. We knew it just made us live better lives as engineers and helped the business deliver better. And so it was just a better way of working. And so I think it's really important that people understand that we're not doing things like this just to do things like this. We're trying to help the business goals, but we're also trying to make it a better place to work.
Yeah, and the metrics kind of give you an opportunity to reflect on how you're doing, right? See where you could improve, see how you could sleep better, right?
Yeah. Well, and that's the key thing is, the metrics don't make anything better, but they tell us when things are going off the rails when we're trying to improve things. And, somebody just asked a question here about, where should teams start when they want to improve? And absolutely, teams should start with continuous integration because number one, the CI metrics are going to be leading indicators for everything else that's going to come. Are we going to improve the flow of delivery? Are we going to be delivering more frequently? Is our quality going to be higher? But the activity of trying to do continuous integration and real continuous integration acts as a forcing function for uncovering a lot of the problems that we have both inside the team and external to the team, where either, things like we have CAB or we have external dependencies to the team that take us a long time to meet. We can't get the information we need. We don't work well as a team. We don't test well, or just lots of different dysfunction that you'll see frequently on teams that aren't implementing CI. CI is the tool to uncover that. In fact, a group of us got together at DevOps Enterprise Summit last October and put together a website, minimumcd.org, that, and Accelerate talks about how continuous delivery makes the organization better, reduces burnout, reduces deployment pain, improves morale. But the reality is that most people who are doing CD aren't seeing these outcomes because they're not actually doing continuous delivery. And we decided to swarm around this problem and come up with what are the minimum set of behaviors that absolutely will uncover the systemic issues in your organization, that when you improve these things, you will see these outcomes. And CI is at the core of that. We always tell people start at CI.
Yeah, I think, my perception of one of the stumbling blocks that people have with metrics is the idea that it's somehow going to be used, like weaponized against them, right? To make
It's a
sure.
huge fear. Yeah, absolutely.
Yeah.
Yeah, and anytime you show people a dashboard, if you approach it the wrong way, they're going to be terrified of it, because it's the, most organizations are very much command and control, and they're not focused on how do we improve the organization. You people need to do better. Well, it could be that the system they're working in doesn't allow them to do better. And if you approach the metrics from the point of view of, I'm holding you accountable to the metrics, instead of, we're using these metrics to help identify where we have systemic issues in the organization so we can improve things, then you're going to have fear and mistrust, and the metrics will be complete garbage. Because the data, underlying data of the metrics, depends on people caring about the metrics.
Yeah, that's really important, right? I mean, everybody should, ideally, you'd want people to be kind of excited to show off the metrics, right? But to get there, you really kind of have to build that culture of not blaming people, right?
Yeah, I mean, one of the things that I was trying to do in the dojo was organize metrics in a way where teams could go, oh, hey, they've done really good. I need to go talk to that team over there, so that we could not be a central source of good ideas. We didn't want to be a center of excellence at Walmart. We wanted that to be federated across the organization. But yeah, I mean, these should be things where it's like, hey, look, this is what we're doing, and how can we share and help each other, and just keep those things transparent. But of course, it requires that trust. We need organizational trust to be able to reach our improvement goals for the bottom line. I mean, if we don't have trust in the organization, the customers suffer, and so do our business goals.
Yeah. So I captured a screen capture during your slide presentation. Is a slide on metrics relationships.
Oh, yeah.
It's a really good slide, and I was hoping you might be able to talk about that a little bit.
Sure.
I can read it back to you if that helps.
Well, what would you like to know about it? I'm sorry.
All right, so you have broken it down into five categories: business and customer value, objectives, flow, continuous delivery, and continuous integration.
Yeah.
My sense is that management really wants to know two things. How are we getting better at managing our project, and are we on schedule and budget, right? So that I would think that the management's really going to be focused on that business and customer value category. Can you talk a little bit about some of the metrics that are useful there, and really?
I think the key thing there to understand is each, the underlying layers are leading indicators for the lagging indicators that are above, right? And so, if you're trying to improve our ability to be, on budget, on time, then we have to become more efficient, and we also need to find ways to become more sustainable about what we do. So number one, our budget and our time schedules aren't based off of fake data, right? I mean, we can't just pull that out of thin air, but a lot of times we don't have good data to base that on, because we're making assumptions about how things are going to work because of people working heroics and getting burned out. And then we make business plans around current heroism as if that's sustainable, it's going to go forward. And then of course the business plans fall apart because people leave, right? Or the quality drops in the toilet. So, if you're an executive, pushing on the things that will act as forcing functions to help us become more sustainable and more efficient, and then really focusing on, from the business side, how do we become more effective? How do we get better ideas through this more efficient, more sustainable delivery process, right? I mean, it's also very important. Doesn't matter if you're very efficient if you're delivering garbage that nobody wants. But, they're all tied together, and you have to understand how those interactions impact each other. And your bottom line is absolutely dependent on people working in ways where they don't have tons of process overhead, where they're not just struggling every day to get their job done, right? I mean, developer experience is another thing that I think is incredibly important. How do we remove friction from the ability to go from idea to delivery?
Yeah, so it's a really great point. So if the metrics are kind of a trailing indicator and an opportunity for you to adjust, in order to get good data, you have to ask yourself, are you creating good estimates? And if you think you're creating good estimates and you're not on schedule with the estimates that you have going in when the metrics come out the other side, you got to take that opportunity to really reflect on the reasons for that, and try to implement some sort of change there, right?
Yeah, I mean, how can you deliver what you want to deliver if you don't first become predictable? And the only way you're going to get predictable is by making sure that we have a healthy organization that can predictably deliver. How can you, I don't want to use an assembly line concept, because it's not assembly line. I mean, we're doing product development. We're not doing a product assembly. But you need to have a sustainable system of doing the work, or we just can't be predictable at all. And any predictions you make are just complete guesswork, and you're going to only disappoint people.
Yeah, there were some really good quotes in the latter slides there. Two of them. The first one is failure is not an option, and the other one that I saw was don't measure people, invest in them.
Yeah, and failure's always an option. The only optional thing is how we respond to failure. Right? I mean, so you can either punish failure or you can prepare for it. And if you prepare for failure, then you'll fail much less and much lighter. But yeah, the fact of the matter is, and this goes with many topics, the software industry really is depending on, you get college graduates coming out who've learned computer science or MIS and how to code. But they haven't learned software engineering. They haven't learned security. They haven't learned how to test. And organizations basically expect us to know these things or to become hobbyists and try to figure out the best sources of information on our own at home after work. And so basically you're betting your organization's success on our ability to find good information in isolation, instead of dedicating an effort to investing in your organization's success by making sure people understand how to do secure coding, how to architect tests well, and do these things, and ongoing training for your organization. And I think that that's really risky. People shouldn't do that.
So you're kind of advocating then for kind of using your metrics to figure out what the areas are for improvement.
What gaps do we have? What organizational gaps do we have that are showing up, and how do we address those gaps more globally?
Yeah. So what are some of the most common gaps that you see that people can get and address from their metrics? Let's say like an early formative sort of phase of a project.
Well, so CI, of course, is going to uncover a lot of pain. And I gave a talk a couple of years ago called Why Can't We Do CD? And it was based off of information that I'd gathered from our organization, working with teams daily, and also from comparing notes with other dojos. And the common struggles teams have is, people are used to delivering giant batches of work with a lot of exploratory coding, like we're not really sure what we're delivering. Teams don't know how to test well. And I'm not talking about they don't know how to unit test. Lots of people know how to unit test. I mean, they don't know how to really exercise an artifact to make sure it should be delivered to production in the pipeline. They don't know how to architect tests for continuous delivery. That's a skill. They don't know how to break down work very well. They're used to user stories with some vague acceptance criteria, and then they go and try to figure it out as they go along because that's a technical detail, instead of getting down to, we have very high certainty we know what this particular story is, and in fact we can deliver it in 2 days or less. We know that because we have a very high certainty of what it is we're trying to get done and how to test it. Teamwork is also a big struggle. You find that managers like to assign work to teams. Hey, here's your 4 stories for the sprint. And it's never supposed to work that way, because then what you've done is you've taken a team of, like, say 10 people and turned it into individual teams of 1. Nobody cares about any work but their own. instead of what are the team deliverables. And so, focusing the team on teamwork, and we are using a pull system to do work. The next person who's available, take the next item of work, and let's help each other deliver that, because if you fail to deliver, we as a team fail to deliver, not you. And so those are some of the really common problems that most teams are struggling with.
Oh, that's a really great point. Can you maybe pull on that, give it like an example of like instead of just individual tasks and individual effort tracking on tasks, how you can build tasks that are something that allow the team to work together on a task.
I mean, there's lots of ways you can do it. I mean, you can do anything from mob programming, where we all work on one thing and we're basically doing a single piece flow, to just a working agreement that says, okay, all of our tasks are going to be very short, where we can get, number one, we're doing CI, so we should be committing code to the trunk at least once a day, probably more often. But as a working agreement, as soon as you have raised a pull request, if that's the method of delivery we're doing, then you should go and see if there's a code review that you can help out with. And hey, let's pair on the code review. Let's not just do comments and then send it out to people. How do we remove the wait time from the process? How do we, what I would tell teams is like, hey, look, if you are done coding and you go see if there's a code review you can do. If there's not a code review you can do, is there anybody in the team that you can sit down next to and say, hey, are you struggling with anything? Is there anything we can brainstorm on the thing you're trying to finish? Because work in progress is more valuable than work not started, right? And so let's drive work in progress to closure. And then only if you can't find anything else to do to help somebody deliver something should you pick something up new. Keep your whip low on the team. Right? It doesn't matter how many tasks individuals get done. It matters how much value the team delivers.
Yeah, so that's a really great example of how you're actually going to use the metric to measure how well you're actually planning your tasking, right? That work in progress load, understanding what that means and how you can use it is a really important point.
Yeah, I mean, you want to keep WIP, the number of things in progress smaller than the number of people on the team. I mean, we should be working as a team to deliver things, not trying to maximize utilization of the team. I mean, what do you call a highway that's maximally utilized? It's called a parking lot, right? And that's not useful to anybody unless you just want to park your car.
Yeah, for sure, right? So we know that things get done faster when people work together, right?
Absolutely. Two brains are smarter than two individual brains. I mean, two brains together, it's greater than the sum of the two. You get a lot better ideas.
Yeah, so there's a whole ball of work there that could be done around designing tasks in a way that allow people to work together on them as a team.
Well, and I always recommend pair programming whenever possible, just because things flow a lot faster. It moves a lot of wait time from it, and you get better ideas. Not everybody is open to that, and I understand that. But we should always be looking for ways to be collaborating as closely together as we can in real time versus having a lot of handoffs and wait time between people. And so your particular context will vary, but from that principle, right? How do we collaborate to get stuff done, push things to completion, get it in production? Because the longer it waits to get in production, the more risky it is that it's wrong.
Yeah, I know this is a big topic, but we got just a little bit of time left. How much time do you think a team should spend at the end of their sprint during like the retrospective on kind of analyzing their metrics and understanding what it's telling them and what it might be able to do to get better?
I think they should be metrics driven. We start with CI. Okay, now why can't we do CI? Well, it's and we use the metrics to see how we're doing, how we're progressing. But then we focus on how do we improve continuous integration, and that's where we start. I also would highly suggest that teams drop to a 1 week sprint because 2 weeks is way too long for anything. It's much more effective if you shrink all the batch sizes. I prefer just single piece flow, but I think a 1 week sprint is something that people can grab onto that makes it a lot easier to improve. When you run a team through a dojo, all the dojos do this. You're running 2.5 day sprints and you're doing retrospectives and demonstration every 2.5 days. And so you can't tell me that I need 2 weeks to deliver something, because I know we can deliver something in less than 2 days.
Wow, that's a really great point. And that, I've enjoyed this opportunity to talk with you today, Bryan. We are unfortunately out of time. Thank you for an excellent talk and excellent discussion.
Yeah, thanks so much. And anybody can reach out to me on LinkedIn if they have more questions, or I'll keep looking at this at the stream if anybody has any questions for me.
Thanks.
Thank you.
I prepped it actually. That's a good one, because I know it's going to come up with the continuous integration. So we have been doing the integration of maybe years. Like even though when I wrote the program from 30 years ago, I was in integration. But what the continuous integration means, that's a little bit going to come back to this graph shortly. So we have various team members, like the team A, team B, team C are building the code, and within their environment, eventually we have to merge this code, and then we have to build that. What build means, like we're just getting a code and then creating a binary artifact. So this binary artifacts, it's going to be used in the production or the testing environment, right? So this is kind of like a build process. They have to understand what the build means. Beta is going to get the code and then package it, and depends on the build steps and creating some binary artifacts so we can use for various things. So now in the concept of the DevOps or the modern thinking, we are adding a continuous term here. We are adding a C term. Like this is kind of like an integration level. Now suddenly we are adding a continuous integration. What the continuous integration means, so we're going to get the code. We will get the code from the repositories. You remember we mentioned about infrastructure at the beginning. So we will get the code plus other artifacts. Other artifacts is infrastructure code. Other artifacts how we're configuring system. Now build that. Now we are building, so creating artifacts, creating and the testing, and then eventually we're going to do the deployment shortly. So continuous integration will help us to gather any changes from repositories we get from repositories, that kind of get change happen in repos and developer pushed it, A team pushed something and B team for the repo, for the person wise or the team. So we can grab the code from repository and package it and then make sure delivering to the staging testing environment. So in the build process, we're not again just getting a code, we are getting other artifacts because the software that we are building right now, there are so much dependencies in the software. That goes back to the SPAN question at the beginning. So we get the code, we get other artifacts, how we are creating a deployment as an example. How are we creating a dependent libraries as another package? And so we get all together. Maybe we're building the code, we're just going to push into production. We don't know what operating system requirements are behind it. And third one is, this is the first time probably you may be hearing that, write the code, we have the infrastructure, now we're adding a documentation in it. So you don't think about that we are creating a Word documents in the context. This is more about specific information about our system. Our system that we are building, maybe some specific user guide that we are creating. Maybe we have some notes that it is relevant to how we are configuring an environment. Maybe some notes that's specific to how we are writing the requirements for the code that we are building. So suddenly build is combination of the code, artifacts, and other documentation, we can build it. Because as a result of the build, we are creating a artifacts. So artifacts is a binary, but sometimes binary is not enough to run with the production environment because you need other information for a security perspective, for a maintenance perspective. I saw so many examples and the bad practices in software engineering thinking. We are running in the build in the production environment. We're never able to go back and reproduce again because we don't have right build steps, right configuration, right documentation, right infrastructure code pieces in place. So the continuous integration is basically combining all of them. So let's look at the continuous delivery and deployment. Let me get bigger here. So I'm just going to give a quick example about the just to set the stage SDLC. So we have the requirements that we write it, and we have the design, kind of like architect as well here. And we have a development and we have a testing. So we are in the deploy that goes in the production environment. So typically continuous integration is happening somewhere here as a continuous integration. So we got the code, we are building. Now we make sure that we have the CI. So continuous integration is going to get a build artifacts for us. What is next? So after build artifacts, there are two concepts. One is a continuous delivery. Another one is deployment. It's often a confused term. So both of them intend to really go into the production environment. So deployment, get artifacts and do some testing or requirement test, including security, and automatically pushed into the production environment. That's kind of deployment goes into the production, which user can see as live as an output as a result of the build. What the continuous delivery is, it is manual to production environment, but it is automated into the staging environment. So as an organization, we need once we build artifacts, we can go to test harnesses. We can initiate the different test harnesses. We can create more test cases, test environment. We can deliver the artifacts into the staging or test harnesses, so we can do more testing for the artifact that we build. When we are done, we can manually put this artifacts into the production environment. That's a continuous delivery, and deployment goes automatically. So next question we may think about that, can everybody do continuous deployment? It depends on the business needs. It depends on the system that we are building. Can everybody continuous delivery? Yes, we should do continuous delivery because that's the intent of the building a software. First, we can test more and more and more. When you're ready, you can manually get artifacts if you want to put into your production environment. Okay. So quick summary, continuous integration will help us to build artifacts from code, infrastructure, documentation, all information. We can package it, version it, then we can test it, the content in the staging environment, make sure everything is working fine, which is delivery. And when we are moving into the production as the users that can see automatically, that's a continuous deployment. So deployment really is specific to the business need. Deployment is specific to the organization. That's an example.
Hello, everybody, and welcome back to DevOps Days in Pittsburgh for 2022. I'm moderating for our next speakers. They are doing a little bit presentation about automating pipelines for container maintenance in highly regulated environments, which is definitely a difficult subject. We have Jose Morales. He's a senior researcher at the Software Engineering Institute. He's done a lot of cybersecurity and malware analysis, and currently he's working with research in DevSecOps. And we have Rob McCarthy. He's a colleague of mine, and he's a DevOps engineer, and he's works with Jose and I, doing all sorts of DevOps tricks and figuring out how to make everything work and what to do. So I'm going to hand it over to Jose and Rob and let them take off.
Thanks, Doug, for that nice introduction. I think you did a pretty good job of covering our first slide. It's really just our title slide introducing ourselves. Like you said, I'm Rob, and I'm going to go ahead and jump right into our first slide in the deck. So right off the bat, we just like to simply cover how your typical container build happens. This is not within a highly regulated environment. This is just you're developing a container at home and you want something simple. You want to serve a Django website. No frills, no thrills. You just want to have your container built and running. This is how this is going to work. So I'm going to go ahead and switch over to a demo, my VS Code environment, and actually demonstrate what this looks like. So here we're looking at a very typical Docker file. It's built off a Python version 3.9 image. The really important part for those of you who aren't familiar with Docker but might be familiar with Python is that we're installing a couple core Python libraries, those being Django and GUnicorn. Both of those libraries have sub-dependencies. It's an important note for later on. As we install that, we're running a python-m pip, which is saying Python's package manager needs to install those two libraries. And that's going to make a direct call to the internet, which is key for later as well. That call to the internet goes out to the default Python repository, which is PyPy, and downloads those packages that are listed there as well as their sub-dependencies. These are all through calls to the internet, which in a highly regulated environment typically would not be allowed during your Docker builds. Continuing through the rest of the Docker file, we just set a working directory. We do some Django admin stuff to start our project, and we serve the site on port 8000. So that's really all there is to it. I've abstracted this build and deployment a little bit by creating a make file, which is also pretty typical. So we have make build, which will build our image using a particular tag, Python base, we'll tag it as latest. And then make run will deploy the image on my local machine here. and it'll serve it on port 8000. So pretty straightforward. I'm going to go ahead and just run make build so you can see what that process looks like. CD my directory here first. So we're going to go into Python base. Later on in our demo, we'll be working in Python automated. So these are two different folders. So go ahead and run make build. You can actually see here it's making direct calls to the internet to actually pull the base image, that Python 3.9 buster, and then it'll also make calls to the internet to download the libraries. While that runs, I'll switch back to the Docker file in case anybody wants to take another look at it. So here's where it's doing the Python library installs. It's going out to the internet, collected Django, Unicorn, a couple different libraries there that are sub-dependencies of those two top level libraries. So now we have our container. We can actually see Docker images. We have a Python base tagged latest, so as we expect. We'll run make run to actually deploy the image. So now make run has deployed it in the background so we can still interact with our command line. And then I'll just curl localhost 8000 just to show that our application is indeed running on that port. So very straightforward Docker build. This is pretty typical of any normal developer building a container. And then later on, as we get into the highly regulated environment builds, we're going to have some caveats and some ways to work around the restrictions that are imposed by those environments. We'll switch back to our slide deck for now. Now we'll turn it over to Jose, I believe, to do this slide.
All right, thank you, Rob. So now we're going to move out of the world of typical container building. We're going to move into highly regulated environments where things become a little bit more restricted. So first of all, I want to give the definition of a highly regulated environment. It's a digital system or physical space that is restricted to adhere to security requirements. Normally, when you're in this type of environment, you're limited on functionality, you're limited on accessibility. When it comes to building containers in this environment, there's a few phases that are added in, as opposed to what Rob just showed us, which is a straightforward build of a Docker file to create a container image. Inside the HRE, we have a different few extra phases in the pipeline, as you see in the slide on the screen. So first, you have to go through an obtain where, because you're in a highly regulated environment, you normally don't have open internet access. So you have to download all of your required packages ahead of time. That's where the obtain phase comes in. Once they're come in, they're scanned for any CVEs or any security concerns. You perform a build of your image. The build occurs locally with all the packages stored in local storage, as I just explained. And then you do a security scan of the built image for any CVEs, any other security concerns that may come up, anything like that. And then finally, there's an extra step where your built image may have to go through manual review by other folks, security folks, and their suite of security tools. So this is a much longer process than just doing it openly. It can take a few minutes if it's very simple, but typically it takes a few days, 1 to 2 days, primarily because of the review at the end and any security concerns that need to be resolved. So one major restriction in a highly regulated environment for container building is your packages that you're installing can only come directly from the internet if it's in a pre-approved repository and you're using a pre-approved package manager. If it's not available in these repositories, you have to download them ahead of time and store them locally for local install. What that requires is you have to create a declaration list of all the packages that you're going to need and their dependency trees, which for some can be very large. So this is a a very time-consuming process to take every package you require, list it out, figure out all the sub-dependencies, and in the declaration list, you have to give for each one, usually the URL where it's located, a hash, because in that first scan that you see in the pipeline, it's going to compare hashes, the hash of the file you download with the one you provided, and they have to match. You have to give the URL, the hash, and this is for every single one. You make the list, and this is what's used in the obtain phase of the pipeline you typically see in HREs. One problem that occurs here is when you have to preload everything, you have to be aware that changes are going to occur to these packages. When a change occurs to the package, you have to go back to the declaration list, make a change to that specific entry, and then rebuild. In the process of doing that, there's a few things that tend to come up. One is URLs change without notice. So you break the build, you have to fix the URL. A lot of vendors, they update their packages, but they don't update the file name of the package. So you think it's the same version, but it's not. And then that also breaks the hash comparison because now they don't match. But there's a deeper problem that occurs, which is once you've made your declarations list, you build your package initially, you build your image initially, and it gets approved and put out for use. Then you go into a maintenance phase. In the maintenance phase is where we see major challenges inside an HRE. And the key one is when a package has a CVE or some security concern, you manually go into the declarations list, you update it to the newest version that has a patch of some kind. You go through the whole process. The problem comes in that when you update that individual package, you haven't updated anything in its dependency tree. And there's going to be a lot of dependencies that require the old version or have yet not been released for the version you just put in. This creates a downfall of going back into the list, finding the package that has a version conflict, figuring out the version, editing the list, rebuilding the image, run it, another one kicks in, repeat. And this goes over and over and over. And this process is a result of the restriction of having to have your packages locally stored. And you can't just pull the latest version from repositories like you would in an open build. Fixing the dependency tree version conflict can take a couple hours. They can take a couple days. Usually, especially in the CVE realm, you'll get multiple CVEs from multiple inside a singular container. And dealing with them and fixing the dependencies is a manual process. It takes a lot of resources. Now take that in the next slide that you see, where you're going to try to scale that. Take one container. It has 10 CVEs affecting 8 packages. You have to manually fix each of those packages in the dependency list and there's the dependency tree, and then do that across 8 containers. It suddenly becomes an overwhelming task that is not scalable, it's not sustainable, and it's impractical. So maintaining a declarations list in a manual form due to the restrictions of HREs creates an impossible scenario that is very difficult to keep up with. And the result of all that, the obvious conclusion is we need a better approach to fix this problem, which is what I'll switch it back to Rob, and he will now give to you that approach.
Thanks, Jose. That was a fantastic assessment of the problem statement here. So going to the next slide, we're going to be talking about the scalable, robust approach that we've developed after suffering through some of these pain points. Keys to this are going to be creating an out-of-band automation. And what do I mean by out-of-band is an executing environment that is outside of your highly regulated environment that you fully control. It's really important that you're able to control the package managers, how commands are being run, if and how you run Docker containers, and the frequency at which you can do something like a cron job. The automation side can be executed through something like a CI pipeline, but it can also be done through, like I said, a cron job. We'll do the job just as well. So you're going to create an out-of-band automation that essentially uses the power of Docker's reproducible builds to generate packages of your dependencies. So rather than taking a list of, say, 50 dependencies for any particular Python project, you'll have your automation download those dependencies ahead of time and generate a single package. Take that single package, and then you can do all your computes on that and actually serve that to the highly regulated environment pipeline. And your SHA sums and everything will still validate at the end of the day. This way, when something like a vulnerability pops up in one of those particular libraries, you can either rerun your automation, or you can just go and grab the latest build from your cron job. Say you have your build running every single day or every morning. And then when you log on in the morning and you see a new CVE listed for one of your packages, you can simply grab the latest that was built overnight for you. If your automation is going to live on something like a job server, like Jenkins, GitLab, some sort of CI build system, you want to package your automation logic in such a way that a developer sitting on their local machine can easily rerun that same automation and confirm that it's going to work on the job server. This saves them a little bit of time of having to remote in and debug issues. They can just, run their make download dependencies command, and they can get that tarball that they would expect to come out at the other end from the job server. So that's super important too. So I can jump into another demo here to actually show what this looks like from a coding perspective. Go ahead and switch over. So get into my directory again. Okay, so I think the first thing that we should cover is a very straightforward bash script that's going to download the dependencies for a particular set of Python libraries that we want to install. These are the exact same as the previous Docker container that we reviewed. Django and Unicorn are what we're going to be pulling down. The command has changed slightly. Instead of using the pip m install capability, what we're going to do is the pip download. We're going to give it a destination, and we're going to say, hey, we created this directory in the temp directory, and we want to download all of those libraries into temp Python libraries. Now, what pip download actually does is it does almost the exact same thing as pip install, but instead of installing it, it just saves those files locally for us. So we'll get Django, Unicorn, and all of their individual subdependencies at that directory. Then finally, all it does is create a tarball compressed, and that's it. That's all that this script does. So you should expect a tarball to exist at /temp/Python libraries. Now it's going to get a little bit more complicated, because what we're going to do is we're going to run a container that serves this script as its entry point. So when you run the container, it'll have a volume mount to the host file system. The purpose of running it in the container is to use that Docker reproducible build. A lot of times what we see is a highly regulated environment may have any particular, say, build containers for different languages. What we want to make sure happens is that we can reproduce that same build environment externally from the environment. So instead of using Python 3.9, we might be using a Rust compiler image, or the exact same image that we plan on running this on. So that way we know that when we download these dependencies that are looking at that architecture, it's going to be the same in the executing environment. So we run this script as an entry point to our container. And I'll switch over to the make file so you can actually see what those volume mounts look like. So the make is just going to change mod the script so it's executable, and then it's going to create some volume mounts here as it runs the image. So it's going to create a volume mount in the current working directory / application. That's really just looking for the actual code itself, the Python code. The really important one here is the /scripts, because that'll create a /scripts directory inside the container image into the current directory. And then that's where it's going to set the entry point to do download.sh. And it's going to, and it's going to execute that download.sh command when we actually run the container as the entry point. So it'll do this download. Now what the Docker file looks like, it's important that that download is going to create that tarball. So now that tarball will be sitting on our local file system. Now this Docker file is the exact same container image as the first demonstration, but it's changed slightly to expect that tarball to be available in the local build context. So we're no longer doing pip install from the internet. Instead, we're saying, look for all of the dependencies and the libraries that we're expecting at this file path within the container. So in this line 9, is where we actually see that happening. So it copies in the tarball into temp repo, and then it's going to do a pip install no index, telling it not to go out to PyPy. And then it's going to find links, which is the subdependencies of these two libraries within temp repo Python libraries. And that's after untarring that tarball. So it's pretty straightforward, almost the exact same image. And then we're going to expose 8,000 and go ahead and run the exact same entry point to our application container as before. So looking at the make file, we have two more commands. All they do is it builds the application, which is our runtime application, and it runs the application, and then a cleanup command. So go ahead and do a make download deps. Now, if we can see on our left nav there in the application directory, we can see that it created a Python libraries tarball. So now that's available to the Docker file there in that local context. So now if we run make build app, and these make commands are a great example of how your developers can run this type of automation locally without having to, count on the job server, debugging a job server. They can just run these make commands locally and verify that things are building as expected. So now that we have that Docker image, we can go Docker images again. We can see that we have application air gapped. So we have a different tag being associated with this image this time, and it is available to our local Docker registry. So make run, we'll just serve that same image again on port 8000. We'll curl it just for validation. And with that concluding the demo, I'm gonna go ahead and switch back to our slide deck again. And so all of the code that we covered today is going to be available on GitHub. It's already up there right now. You can go ahead and peruse it at your leisure. But that just about does it for the main content of our demo. We really appreciate you listening. Thanks.
Thank you.
So that's an interesting way to get your dependencies in a different environment, Rob and Jose. We had a question from the audience. They were wondering, so how did you archive off your base Buster container for this Docker file? So I'm assuming this gentleman is saying, well, you have this base container. How do you get that over into your highly regulated environment to start with? So that's probably like the first step, maybe, that somebody would be asking questions, because, hey, everybody's used to doing, Docker and then put from and then the container, and Docker just goes out and grabs that container and goes from there.
Yeah, that's a good question. So typically in HRE, you would have a seeded registry. That's usually some images that are already in your registry out of the box that whoever's supplying your HRE has put there for you. If that's not the case, there's a number of things you can do, like Docker save. You can create a tarball and then you can load that in. Usually you would depend on someone who's loaded those tarballs in ahead of you. And if that is the case, then what you would want to do is get a copy of that to use in your from statement. So you would be using that base image in your Docker file rather than the publicly available internet Python image, for example. You may have a hardened Python image that's available in your HRE. You want to get a copy of that, and you want to be using that for all of these builds to make sure that you're reproducible when you go into the operating environment. If that answers your question.
Awesome. Yeah, I think that answers the question, because the same gentleman, Matthew Weber, was wondering, like, how would you patching the base images as well? Would you follow kind of the same, like scheduling cron, grab the image and push it over? Is that something similar that you'd think that would be in use for an HRE?
Yeah, absolutely. This is containers all the way down, right? Container maintenance all the way down the stack. So if instead of building an application here, perhaps we're building another base image that's a derivative of Python, we would follow the exact same process as we're following here to do all of our updates. Maybe there's some libraries that we want to be available downstream in downstream images. We would update them the exact same way. Same with all your base images. As long as you have to pre-declare your dependencies ahead of time, which is super typical in these environments, you're going to have some sort of out-of-band automation to improve your life a little bit.
So another thought is for example, like you did a good Python base, kind of like, hey, this is how you'd make a simple Python app. But a lot of times now, folks are using like package managers, like, you say pipenv or poetry, or like JavaScript where you have npm, where it kind of pre-downloads those hashes and kind of checks and kind of does its own validation as having the correct file under the hood. So how would you see that would be incorporated into this workflow, just off the top of your head?
Yep, that's fantastic. And we're actually doing that. So in some of our production containers, we're doing RPM updates, and we're also doing R package updates. So R package is very interesting because when you do an install packages command, like your pip install, it's going to download the source code and it's going to build from source. So there's a lot more that goes into having the build dependencies for compiling from source, as opposed to installing a pre-compiled binary as your library. So there are things like packrat through R that you can use to download and create archives of those libraries and subdependencies and create that same tarball. Your approach changes a little bit based on what programming language or operating system you're working on, but the functionality essentially remains the same, leveraging something like yum download only, right, is the flag that you would provide yum to grab your RPMs and store them locally rather than just yum install.
Yeah, that's a good point to point out that something like yum or DNF has that same download only flag like pip does, that you can kind of create your own index or your own mini repo if you need to. I think this is probably a good way to look about doing these particular types of builds, since a lot of the newer different types of environments now where people are just used to pulling things from npm or PyPI, and even maybe you're not a highly regulated, but maybe it's something to think about, like, hey, maybe I don't want to just pull the newest packages every time I do a build, because what if you have one of those sneaky people who uploads a malicious package, and you want to look at that before your next build gets deployed. I think we are running out of time and getting ready to go for a break. So, Dr. Morales, Rob McCarthy, I appreciate your presentation. It's a good demo and kind of like a real how-to on how to do it. And
thanks, Doug.
It's definitely a nice presentation. Thank you.
Thank you very much.
Yes, it's a really growing topic right now, Shane, for the SBOM, especially for dependencies or open source, whatever you call about it. I think let's define what the software bill of materials means. It's basically all the software components, that is including open source, including any type of dependency in the application that you're using it, and make them as visible, make them as traceable throughout the life cycle. When we say like a traceable, it's basically we have to know what other components are we are using it, what the versions are we are using it, where we are using it. That's actually two couple of things, like what the version that we have it, and where we are using that libraries in which context, like maybe a server, maybe some of the dev environment, maybe some of them is a build package, some of them is runtime package. If we know that where it is we are using it, so we can be ready for any type of incident, any type of vulnerabilities it's becoming for specific vulnerability for that libraries. Because if you don't know where it is, if something happens for a specific libraries, if you don't know what we have in our infrastructure or the build process or environment, it's very difficult to find that and patch that because we are racing against the time. And like there's a concept of the 0 day, even though the vulnerabilities exist, like identified already in the community, as an organization, if you don't patch that vulnerability timely, that within the application, it is going to be a 0 day still for us. So we have to be very effective with that. How can we do this effectiveness? It's really a good software delivery environment, such as doing a good DevSecOps end-to-end, will help us identify those vulnerabilities, identify this type of libraries easily, or we can keep track that libraries throughout the life cycle. We can go and patch that. I know we're going to discuss most likely, I'm guessing it, because this is going to continue. I think we're going to see how we can build up SBOM as part of continuous integration. How can we build up the SBOM using a single source of truth, as an example? How can we connect the dots so that once we go to the further dive into the question, I will come back again and answer that specifically. Overall, using a good practices and end-to-end life cycle with DevOps component will definitely help us to speed up and be aware for any type of vulnerability, any type of the dependent we are using in life cycle.
Hello everyone. I am your speaker for this current session, and I'm really happy to be here at DevSecOps Days, Pittsburgh. Without further ado, let us shift to the presentation. So I will be sharing my screen now. A warm welcome to all of you. Thank you for attending the DevSecOps Days, Pittsburgh 2022. Shout out to the Software Engineering Institute at Carnegie Mellon University for organizing this event, and I hope you all have a wonderful session. So the topic of this session is DevSecOps in the cloud from the lens of a well-architected framework. A brief about me. Currently, I'm working as an Assistant Director, Cloud Practice at EY, Ernst & Young. Before that, I led the CCOE, Cloud Center of Excellence team at Accenture. I have around 10 plus years of IT experience and have been working on cloud technologies since 2017. A little bit of expectation management before we start the session. This is not an introductory session on how to get started with DevSecOps. It is expected that the audience for this session is already familiar with the concept of DevSecOps at a high level. This talk is primarily targeted at individuals or teams or enterprises who want to understand how architecture plays a crucial role in DevSecOps. That is the overall idea. So what is the agenda? Over the next 25 to 30 minutes, I will briefly touch on these 5 sections. Context and background of what we are trying to discuss and achieve. What is DevSecOps? A very brief introduction, not at all going into the depth. Architecture concepts. This will be meat of the session. And then section 4, the link between DevSecOps and architecture, how we can link these two together. And section 5 is conclusion and how do we move forward from here. Okay, without further ado, let's get started. So first we are focusing on the context and background in section 1. We have come a long way, right? From physical machines to virtual machines to containers to serverless, we have really come a long way. Earlier our focus was primarily on on-prem systems, but then we went on a modernization journey to cloud-based workloads, and now we are in that cloud-native era, so to speak. But do you know what has stayed the same? What has not changed that much? Amidst all this continuous influx of technology innovations and changes, the business requirements, they have not changed. They have not changed even a little bit from where they were, say, 30 to 40 or even 50 years back. Because the business does not care about the kind of technology tool chain or the innovation that we are consuming or we are using. They are primarily focused at their business outcomes. They don't care whether you use GitOps, whether you use DevSecOps, whether you use some very fancy AI, as long as their business use case is being met. So while new frameworks, new technologies, new tool chains, new practices and principles will obviously act as a catalyst and will help us in unlocking potential new opportunities. But at the same time, we should not lose focus that the basic requirement that we need to satisfy from a business standpoint is to have a well-architected, secure workload that can help serve the business use case. That is the most important thing. We need to be able to serve the business use case, the business requirements. And a well-architected and a secure workload goes a long way in enabling that. Sometimes we engineers, we are extremely influenced by new technology, tool chains, new toolkits. They obviously bring a lot of value to the ecosystem. But we should never undervalue the essence, the building block, the glue that binds it all together, which is architecture. And that is what I will discuss in this session. Also, another very important thing is that the requirements for scalability, security, fault tolerance, reliability, performance, these are not new requirements. They have been here, say, 20, 30 years. It's not that this cloud native revolution, all of this brought forward this. No, the requirements were always there. But the paradigm or the technology framework or the tool chain that we used to practice or implement has evolved. And now we have better tools in our arsenal at our disposal to be able to meet our business requirements at scale. But that is only possible if we do not compromise on the basic architectural tenets. But this leads to some questions. We were doing fine till now. Why do we need to pivot to this new way of working? Why do we need to embrace this so-called DevSecOps? Will it really enable us to fulfill our original business requirement of having a well-architected, secure workload that can serve our business needs? So we should only adopt DevSecOps if it helps us in achieving our business goals. What is the business goal? The business requirements with a well-architected and secure workload. To be able to answer this question, we need to understand at a high level what is DevSecOps, what is architecture, how can architecture play an important role in DevSecOps. So now we move to the next section, section 2, where we briefly discuss what DevSecOps is. So at a high level, DevSecOps stands for Development, Security and Operations. It's an approach to culture, automation and platform design that integrates security as a shared responsibility throughout the entire IT lifecycle. So traditionally what used to happen in most environments, security is mostly regarded as working in silo and is regarded as an afterthought. Once my software development is done, I used to spend maybe 1 cycle, 2 cycles just on security reviews, on security testing, penetration testing and all of that. So security was more like it's the responsibility of a single security team. From a developer perspective, from a product manager perspective, I don't need to care about security. That was kind of the idea. But with the advent of DevSecOps, this kind of philosophy has changed, where we treat security as kind of that glue which binds all the teams together. Security has become a shared responsibility throughout the entire IT lifecycle. It's not that only some teams will focus on security, only a CISO team or a security team will focus on security. No. With DevSecOps, everybody focuses on security, and security becomes a shared responsibility across the entire IT ecosystem, integrated from end to end. Thinking about application and security, infrastructure security should start from the beginning. This is what we need to do. We cannot think about it at the end when everything has happened already. We need to start injecting security at relevant places within our software development lifecycle so that we do not come with a surprise at the end. That is the overall idea of DevSecOps, which I think all of the audience kind of knows. That DevOps, security, everybody needs to work together, and security is a shared responsibility across all the teams. If you see, DevSecOps has really kind of kickstarted. This is a report by the Cloud Security Alliance in 2021, where you can see most of the enterprises are already in some phase of their DevSecOps journey. Some are refining their strategy, some are designing their pipelines, some have already started the planning phase, some are already implementing DevSecOps today in production. So DevSecOps is a very, very hot topic. But we should never lose focus, as I said, on our architectural tenets, on the basic building blocks that kind of glue everything together. Today there is DevSecOps, today there is Kubernetes, today there is container orchestration serverless, tomorrow there will be something new. But the underlying foundation is very important for us to understand and capture and embrace. And this is why in this section, we go in detail on what architecture is. So all of us, we talk a lot about architecture, about well-architected systems, about how this kind of parameters can affect our architecture. But what is architecture? Can we define it in a way that is easy to understand? This is a IEEE definition of architecture, which, as all IEEE definitions are quite complex. The fundamental organization of a system, embodied in its components, its relationships to each other, the environment and the principles guiding is design and evolution. This is a very complicated definition. Again, this might be a very good definition, but I want to have a definition. I want to leave all of you with a definition that is very easily consumable, that you can directly relate to any other part of the IT ecosystem, be it security, be it DevOps, be it DevSecOps. This definition by Grady Booch, who is a very well-known architecture person and an IBM fellow today, he says architecture represents the significant design decisions that shape the structure and behavior of a system, where significance is measured by cost of change. This is a very good definition. much simpler than the IEEE definition, but still not consumable enough. How do I define it to a layman? So now we go to Martin Fowler, one of very well-known architecture personalities today. So he defines architecture as a set of design decisions that must be made early. So any design decision that has to be made early on in your project is a architectural decision. That is his definition. I like this definition a lot, but I always couple this with another definition of architecture, which is this definition by Matthew Parker. He says, architecture in the field of software development are decisions that are hard to reverse. So if we combine these two definitions, then what do we get? We can then define architecture as a set of significant decisions that need to be taken early on in the project lifecycle. Why? Because they're very hard to reverse. And if you try to reverse them at a later point, there is a significant cost associated with reversing or changing that decision. That cost can be effort, time, budget, whatever. So any decision that is hard to reverse and as such needs to be taken early on in your project lifecycle is an architectural decision. Can we find some examples? Let us take some examples. So if we focus on the second example here, so whether we need to go with a synchronous API based communication or we want to go with an event bus based asynchronous messaging system like RabbitMQ or AWS SQS can be an architectural decision. Because if you decide how you want to structure the communication or the messaging system of your application, 6 months, 9 months down the line, it's very hard to change it. There's a significant cost associated with this thing. That is why we need to think about it very carefully. Another example, which is a very simple example, is what programming language do you use for your application development? Seems like a very simple thing. Why should it be an architectural decision? But it is also. Why? Because it's very hard to change it. Say you have written a program in Java. After 1 year, if you have to write it in C# or Node, it's a very difficult thing to do. So these are some of the architectural decisions. And this is a very simple definition of architecture. Decisions that needs to be taken early on and which cannot be reversed easily are architectural decisions. But then who are we? Who are architects? So this is a very nice picture that I really like when I explain architecture to people. Here I am showing a cuboid, but to the person on the left it seems like a circle. To the person on the right it seems like a rectangle. What it is? Is it a rectangle or is it a circle? The reality is often more complex. And in any IT architecture project, in any modernization project, in any digital transformation project, you will always come across this kind of scenarios where the reality is much more complex. And that is where an architect adds value. And architects have a holistic understanding of the system across a different spectrum of views, and they have a different perspective of the system. They can look through the system at a 360-degree level, at a 10,000 feet. They can look at all the integrations of the system with the other systems in the IT ecosystem. And they can give you that perspective that maybe a team lead or maybe a software developer might not be able to give you. That holistic understanding of the system, that is the value addition that they bring to the table. Gregor Hoff, who is a very well-known enterprise strategist, right now working in Amazon Web Services, he used to say the architect doesn't have to be the smartest person in the room. Instead, they make everyone else smart. So an architect is the person who takes those architectural decisions, those tough decisions that are very hard to change going forward. And it is based on those decisions that your system is designed. So an architect plays a huge role and adds a huge level of business value, architectural value, and a lot of value to your engineering practice by giving you that high level holistic overview of the system. But why do we need architecture? What is the real need of architecture? So this is again a very nice quote that I really like personally. If you think good architecture is expensive, try bad architecture. Many times we architects, we try to take a high model ground and explain to people, no, well architected framework should be implemented. Good architecture should be implemented because it is the best thing to do, which is true. But our clients or our business will not care. We need to explain to our business why architecture is important. So bad architecture or no architecture slows down the ability of our customers to compete as it becomes harder and harder to ship new features. Let me explain this. So if you see this graph, this is called the design stamina hypothesis. So there are two lines here. One line is the good design, which has architecture inbuilt. Another is the blue line, which is the no design or no architecture. If you see, the blue line is a little bit ahead of the orange line at the beginning. Why? Because for the first few sprints, the orange line was focusing on architecture. So it was not able to deliver actual functional user stories. Whereas the blue line from day one was delivering business value, but no architecture. So over time, the velocity is decreasing, because if you are changing something in one part of your application, something else breaks in some other part. You are not able to extend. The architecture is not extensible enough. It is not maintainable enough. When the business is coming to you with a new requirement, you are not able to implement it quickly enough. So your velocity, or the rate at which you add business value to your client, is decreasing. Whereas in a good design, it is starting slowly maybe, but it is consistently adding value to your design. It's a well-architected design. What does that mean? It means if I change something in one part of the code, nothing else breaks. I can very easily modularize my application and add new components. My architecture is scalable enough. It is well documented. It is extensible enough. So architecture matters. This is what I want to say. Architecture really matters. It does not only matter in a theoretical sense. It also matters in a practical sense, in the ability it gives the business to compete in the market by having a high velocity with which you can ship features. So, okay, what is agile architecture? Is agile something that is the opposite of architecture? Because in agile, we are supposed to move fast. Will architecture not stop us? No. Agile architecture is this concept of immediate architecture, the architecture you have right now, and the architectural intent, which is the target state that you want to achieve. And this journey from immediate architecture to architectural intent is the roadmap. The good thing about agile architecture is your immediate architecture is also changing. Your architecture intent is also changing with time, but they're aligned. What do I mean by aligned? If, for example, your architectural intent is to have a loosely coupled, well-distributed microservice application, then your immediate architecture cannot be a monolith application. It can be a small subset of your main architectural intent. Maybe it does not have authorization. It might not have traceability. It might not have logging, but it is still aligned. The immediate architecture and the architectural intent is well aligned. So not having a design based on a strong architectural foundation will ultimately lead you to not being able to achieve your business objective. Be it security, be it scalability, be it anything, you will not be able to achieve that. But architecture is extremely complicated, right? It's not only design. It's not only non-functional requirements. It's not only business strategy. It's a lot of things coupled together. But to get started and to make some impact, we can try to simplify it at a high level. And for now, let us just focus on one aspect of architecture, which is non-functional requirements. What are non-functional requirements? These are requirements that originate from your business, but are calculated or are based on your architect's interpretation of the system. What are they? Scalability, reliability, efficiency, security, maintainability, extensibility, testability, observability. There are many more. Deployment, performance, cost effectiveness. These are some other non-functional requirements. As a cloud or as a software architect, we need to ensure that our design is compliant with these non-functional requirements. Our design needs to be scalable. It needs to be reliable. It needs to be efficient. It needs to be secure. It needs to fulfill all the non-functional requirements that we need it to be. This is the main idea of a well-architected system. A well-architected system respects the non-functional requirements that the business has asked us to implement. So one small thing that you might observe here, that the NFRs that I discussed, these are not new stuff. Even in the world of cloud native, in the world of DevSecOps, in the world of AIOps, MLOps, this will not change. If we can create an architecture we can create principles and policies and practices that help us in achieving these NFRs, then automatically we will end up with a well-architected system, with a secure system. So the cloud might be new, the concept of DevSecOps might be new, the concept of DevOps might be new even, but the essence of architecture, these non-functional requirements, have been there for a long, long time. So now, how do we link DevSecOps with architecture, with well-architected frameworks? One important thing that we need to understand here, that nothing much has changed in the cloud-native architecture world, in the DevSecOps world. Obviously, every new tool kind of ecosystem brings with it new tools, new tool chains, new practices. But the attributes or the constraints or the non-functional requirements that we needed to maintain in the data center, they're even relevant today. They have not changed. Moving or migrating to the cloud or to any cloud-native architecture or to a serverless architecture does not mean that we do not need to think about security anymore. DevSecOps or implementing DevSecOps does not automatically imply that all of my non-functional requirements will be automatically satisfied. No, we need to design the system in such a way. We need to design our pipelines in that way. We need to inject the principles of security into every layer in such a way that we are able to satisfy the same non-functional requirements. Yes, the toolchain that is available today is much more robust and much more easy to consume. Okay, but then what are well-architected frameworks? Every cloud today, AWS, Azure, GCP, all of them have well-architected frameworks. These are basically a set of best practices that many architects have come and thought and written down. These are a set of guidelines, general principles that if you follow them, most likely you will have a very good, well-architected system. That is the idea of a well-architected framework. They enable you to come up with a well-architected system, which is scalable, which is reliable, which respects all of those NFRs that I talked about. So this is our AWS well-architected framework. Some of the pillars are reliability, security, operational excellence, performance efficiency, cost optimization, sustainability. Sustainability is a very new addition. So let us focus on security. Security is a pillar of a well-architected design. That is true. Security is very, very important right from the start. But the security pillar in the well-architected framework is not just related to the security non-functional requirement. It is even related to other non-functional requirements like reliability, performance, deployability. How? This is the idea, right? This is where we link DevSecOps with architecture, with well-architected frameworks. So let's take an example. One of the primary activities that any person who gets started with DevSecOps normally does is we have a CI pipeline and we implement some security tools there. It can be check marks, it can be SonarQube, it can be white source, it can be aquasec, whatever. So we try to inject some of the tools in our pipeline. This is something that anybody who starts with DevSecOps normally starts doing. But let us consider this is not there. We have not done this. We have not shifted our security left. In that case, what is the result? There is a chance that some of those vulnerabilities, which could have been identified by that tool if DevSecOps was implemented, will not be identified. So they will be there in the final released product. Now they could either be discovered maybe during some sort of a penetration testing or something by the testers, or maybe they will be directly exploited by malicious actors when we will get some sort of an alert. At that time, we might need to patch our code. We might need to patch our libraries to mitigate that vulnerability, right? And this might result in downtime. I might have to shut down my application to protect my application data from vulnerable sources, vulnerable actors, threat actors. So what is happening? The lack of DevSecOps practices is not only impacting the security of my application, it is in turn impacting another non-functional requirement, which is reliability. So you can see all of these are kind of linking together. Let's take another example. Same thing is happening. We have not injected DevSecOps into our pipeline. We have not shifted security left. So what we do all our testing at the end of our pipeline. So once my code is done and I'm supposed to release to production or to say staging, for example, and I sent a request to my security team, they come in, they start checking my product. Say, for example, they have found a vulnerability and they say, no, this is a very critical vulnerability. You cannot release this code to production. So what does that mean? That means a lack of DevSecOps is actually resulting in my application not being deployable enough. So I cannot deploy my application when I want to because I do not have security injected in my pipeline. So basically, again, here, DevSecOps or the lack of DevSecOps principles, practices is impacting another important non-functional requirement in software architecture or design called deployability. So you can see the lack of DevSecOps or not having DevSecOps is not only impacting the security posture of my application, it is also in turn impacting my deployability, my reliability, my availability, and other NFRs. So this at a high level, what I'm trying to say is that the DevSecOps principles, this basic idea of security being a shared responsibility, this can be considered as an extension of our original non-functional requirements. So this is very important to understand. And this is the idea that I want to end with, that DevSecOps is not the target. The target is to be able to achieve my business objectives, have a well-architected, have a secure product or project or system. But to enable that, to be able to justify or satisfy my non-functional requirements, to be able to satisfy the well-architected framework pillars, I need DevSecOps. This practice and this principle of DevSecOps is not just about fancy tools and culture modification. It is strongly intertwined with architecture as well. So in this last stage, which is the conclusion, I want to conclude with this diagram. So if you see, at the heart of it all is architecture. At the heart of it all is non-functional requirements. We need to ensure that whatever practices, whatever principles, whatever kind of design methodologies we are implementing is based on these foundations of architecture. We should always consider our non-functional requirements as a very important metric that we need to satisfy. And to satisfy our non-functional requirements, we need to adopt these modern tool chains and modern methodologies like DevSecOps. DevSecOps is an enabler to helping me as a developer, or as an architect, or as a system engineer, as a product manager, to be able to achieve my non-functional requirements. If I can achieve my non-functional requirements, then I can achieve my business objectives. So DevSecOps is actually leading the way to achieving my business objectives. So today there is DevSecOps. Tomorrow there will be something else, some other awesome principle or practice will evolve. But at the fundamental level, beneath everything, the basic tenets of architecture will stay. It will be as relevant today as in another 100 years. With this, I want to end this talk. Thank you so much everyone for attending this session. I hope you had a great session, and I really hope that you have a wonderful DevSecOps Days Pittsburgh, and stay safe and do a lot of good stuff in the world of security and DevSecOps in the future. Take care.
All right. Turja, we love that talk. I'm here for some live Q&A, and I have a question for you. So after listening to that talk, we think of DevSecOps, it embraces Agile. But at the same time, Agile is often thought of as the opposite of upfront architectural design. What are your thoughts on that?
So thank you, Joe. And it's a really good question, very frankly. But that is where, that is the kind of idea about architecture that we want to break, right? So with the concept of agile architecture, right now, we don't want to do a lot of upfront architecture. Okay, we want to keep it agile, just like in agile, you break something into sprints. You don't do everything at the beginning like you did in waterfall. Similarly, the old waterfall way of doing architecture, we don't want to do anymore because it's not flexible enough. So the concept of your immediate architecture and your architectural intent comes into place. And your journey from your immediate architecture, which is where you are right now, to your final architecture, which is the architectural intent of the system, is what we call the architectural roadmap. And the good thing is that both of them will vary. Your immediate architecture will change over the sprints, as will your architectural intent. But at all times, it will be aligned. So if your final or architectural intent is a microservices based application, loosely coupled, distributed, extremely observable, scalable, fault tolerant, resilient, then you should not go in your immediate architecture with a monolithic type. You might have a small subset of the target architecture. You might not implement observability. You might not implement authentication or authorization, but at least you should still decouple your monolith into microservices. So this is the overall idea that we want to embrace, that architecture is not the enemy of agile. It is actually something that really matters. And it matters in a very, very financial sense because it gives you, the customer, the ability to compete in the market. Because without architecture, over some time, you will not be able to maintain a good velocity, will not be able to deploy features. That is the idea.
Excellent. Thank you for that answer. And one more question, it would be, okay, so if I'm an architect designing a DevSecOps integration pipeline for my cloud native workloads, if I don't have the flexibility to implement all the NFRs, what's the most important ones I should focus on?
See, again, that is what we always think, okay, we need to make this application scale to 10,000 instances, but maybe you have only 200 users. It's an internal application. You don't need that kind of scalability. Kubernetes is not the answer. Cloud native is not the answer to everything, right? Similarly, DevSecOps might not be answered to something, a very simple application where you are not that much concerned about security. So your NFRs, your non-functional requirements or your architectural attributes or your quality attributes should come from your business. If it's a banking application, your primary NFR will be security. Your main focus will be encryption, compliance with governance standards. Whereas if it's, say, for example, a web-based shopping application, your primary focus might be scalability, might be that the site should always be up, might be that your shopping cart and checkout option is always up because that is what gives you money. So your NFRs is completely dependent on your business requirements. And obviously, as an architect, whether it's related to DevSecOps or security or anything, your job is also to have something we call as architectural trade-offs. So trading off one NFR for the sake of another, because you will never be in an ideal world where you will be able to satisfy everything. Even if you can satisfy everything, your budget will not be that much. So somehow or the other, you will have to compromise. And this is what is called architectural trade-off.
Very good. So I believe that is the last question we have for you. I really appreciate the talk you had, and you get to close out a fantastic day.
Thank you so much. It's a pleasure.
And with that, I believe we are ready to go in, and what we'd like to do is kind of recap all the speakers that we had today. It was a great day. I know it's a long day for everybody. Really appreciate everyone attending. You know, it's this community, this hearing about how we're all doing this is what makes it better and how we improve this. So again, it's been a great day. Let's talk a little bit about what we got to see today. So DevSecOps Days 2022. So we kicked it off with Chris Hughes, and you know, his talk was on, are we there yet? You know, DevSecOps is about the people, the process, and the technologies. There's good and bad as the CI/CD pipelines. The good is we're delivering software faster than ever, right? We're enabling security tools and robust tool chains. But the bad is it's a new attack surface, right? Our actual CI/CD pipeline is we don't have a unified pipeline necessary, and now we're seeing targeted attacks against that pipeline. He talked about there being many options. Organizational governance is a solution to that. Open source is used heavily everywhere. So dependencies add problems, support based on volunteer time. He talked a little bit about container security and secrets management. Non-automated human actions add uncertainty to the process. Cultural change, it's tough, right? And then at the very end, we talked a little bit about SBOM. SBOM as being it'll help with this problem. If we can identify where software exists in our environments, then we might be able to react to them. All right, our next talk of the day, we had Tracy Bannon come in and hashtag no hobbyists. They say, she talked a little bit about developers are often our security hobbyists, right? And we can't be there, right? So let's not start coding right away. She talked about let's really think about shifting left everywhere. We have to design in, right? We want to bake in security. It starts at the beginning. We talked about this a lot, shift left. A little bit about building a new culture, right? But don't start from scratch. There's been a lot of work already done, right? So developers aren't our answer. They're not wizards waving wands to stop the hackers. That was a great slide. These drawings, by the way, will be available for everybody. And kudos to our artists who got this together as our presenters were presenting. Tracy also talked about security by design. We got to think actively, make decisions. We need to understand the domain. Threat modeling is important. If we don't plan for these activities, we won't do them. That's how we're baking in security. And then, Tracy's a great speaker. She also thought, hey, be passionate about testing. Allow us to be creative and experiment to, give our folks a chance to do this right. Now, next talk, we had, we talked about supply chain risk. This is Steve Kinman from Sneak. It was a great talk. Are we forever doomed by software supply chain risks? So really talked about open source being, again, prevalent, the building blocks of most of our code. Talked about how is this data provided? How are we going to use it? Each section of lifecycle has a risk. All right. So a little bit about the success of the digital revolution. It makes software apps created faster and faster, but we're often reactive to this. Our reactive approaches are always behind the attackers. So now with the developers being targeted, right, we are targeting our tooling. So supply chain risk, it's a weak link. The people are often the weakest link in the security chain. So Steve went into his talks on supply chain management and what we got to do to get better here. Multi-factor authentication, strong passwords, code checks. All right, then Nikki Robinson. So Dr. Robinson came in and talked about chaos security engineering. So this was a fantastic talk. Chaos engineering is still relatively new. She said she was just into this for the last year and a half, and boy, has it come a long way recently. Again, chaos is there. We want to sprinkle a little bit in, maybe not too early, but as soon as we can, that's how we begin to get better about this. So this is a great graphic. She talked about how to integrate continuous security to help developers during creation. A hypothesis-based approach asking, hey, how do I break this? Like in science, a surprise hypothesis is more interested than the expected answer and leads to more questions. So let's leverage our developers' interest in testing and trying things out. We jumped into Bryan Finster from Defense Unicorns. He talked about metrics, the good and the bad, and how metrics can be abused and what we really need to understand, right, about what we want to measure. So he talked about a little bit why we can't release every day, right? We want to align teams to business domains. We want to loosely couple architecture. we're going to create a CD platform team, right? He talked about his lessons learned, how they decoupled the system, they scaled better, they got better outcomes. Why can't we deliver today? They uncovered organizational issues. He noted how CD improves outcomes and morale, and that they just needed better metrics, right? So in closing, he said, hey, metrics are critical, but we cannot measure our own way to improve. We need to use them to monitor and inform the next improvement, right? So we don't want to measure people, we want to invest in people. Next, we had Rob McCarthy and Jose Morales. They're at the Software Engineering Institute, and they talked about a really important topic, which is container maintenance and HRE, so highly regulated environments. Many of us are working in the latest containerization stacks, Kubernetes. They talked about their experiences in building containers and then building those containers in environments which are more challenging, often air-gapped, or environments that have more critical regulations on them. So they gave a nice talk on, here's an approach to doing this in HREs, right? This is a really good talk. This is a really nice slide that captures what was going on. And lastly, Turja just gave a great talk on DevSecOps in the cloud from the lens of a well-architected framework, right? So even though architecture was often a heavy upfront load, today we want to allow it to be, we want to allow that to be an agile process too. We want our feedback in and do these things from his perspective, right? Architecture is the glue that holds everything together. We want to embrace DevSecOps to enable the architecture to guide us and grow with us. So I love these graphics. Great job by the SEI team that created it. All these slides will be available. I believe now you can probably download these from our website. If you have any questions, please reach out to the team. This was a great day. Thank you everybody for your participation. Oh, and I'll leave this slide up for us.